Okay, so recording has started and we'll be discussing today schedule management and earned value management. These are the two topics that we are going to go through. Uh, so let me open PMBOK. In the PMBOK, we have this project schedule management. This is what we are going to discuss. And here we have these processes. So what are the outputs we are going to get? Let's try to find out. You can check that page number. I don't know if you have still printed the Ricardo's chart or not. If not, just check the page 62, not 62, page 126, where you have list of all project documents and project management plan. So what are we going to get here? Plan schedule management. I hope you know plan X management. The output is X management plan. So plan schedule management output will be schedule management plan. Where are we going to keep this? When we define activities, what do you think? Check the page number 126 of the PMBOK. (126) of the PMBOK. Which document are we going to get here when we define activities? Page 126, you have the list of project documents there. What do you think? Which document, in which document we are going to put the activities? Anyone? You can speak verbally only, rather than texting. I can't see the texts and all. Activity list, that's correct. And it's there in the on page 126 in project documents. Right, activity list. And along with activity, we also generate another list, which is the milestones, right? So milestones is also there. You can, yeah, that is also there. But in the PowerPoint, they have not really mentioned activity attributes. It's there as per PMBOK. Activity attributes is also there. Activity list is also there. Milestone list is also there. So you can consider activity attributes as well. But I'm just saying that it's not mentioned in the PowerPoint, but still, I think it's important to know. And activity attributes will be just additional information about the activities, some other information, other details. Just like we had WBS dictionary for WBS, for activity list, we have this activity attributes, few other properties or characteristics of the activities we have here. When we sequence the activities, so see, in order to develop the schedule, you need three things. First, list of activities. Second, how these activities are related to each other. Third, duration of all the activities. If you know these three information, then only you can develop the schedule. Otherwise not, right? So first process on the top 6.1, that helps us in defining the rules, the guidelines and stuff. Second process helps us in identifying the activities. So we get the activity list. So we got one of the things that we need. Second is sequencing activities, which helps us in understanding the relationship between the activities. So that is sequencing. Okay. So once we get the relationship and the activity, we now want to know about the duration of each activity. Once we know these three things, then only we can develop the schedule. Remember, you cannot develop the schedule until you get these three. Just think about it. If you know the activities names, all the activities, let's say 10 activities are there, you know the names of activities, you know the duration of each activity, but you don't know how these activities are related to each other. Can you develop a schedule? No, right? Because you won't be able to sequence them, right? So that's why we need these three processes: define activities, sequence activities, and estimate activity duration. So when we sequence activities, what output are we going to generate? It will be like a a web of all the activities, how they are connected to each other, you know, through arrows and stuff. So do you see any output in the project documents? Something which you'll get from here. When you sequence the activities, that means when you put a relationship among the activities, links, arrows, and stuff, what are you going to get? Look at the project documents. Network diagram, right? So project schedule network diagram. So a network diagram is what you get when you put these relationships. When you estimate activity duration, this is easy. Look at the project documents. What are you going to get? When you estimated cost, yeah, when you estimated cost, you got cost estimates. When you estimated resources, you got resource requirements. Now you are estimating activity duration, so you get duration estimates. Actually, along with that, you also get basis of estimates. But in the PowerPoint, they have not mentioned it. But if you go through PMBOK, you will see that basis of estimate is also there. What is basis of estimate? Basis of estimate means on what basis have you come up with that estimate? It's your justification for the estimate. Like, what was the whole basis of estimating this, right? So that's basis of estimate. Your assumptions and stuff you can mention there. Finally, what are we going to get now? When we created WBS, we got the scope baseline. Schedule baseline. When we created WBS, we got the scope baseline. When we determine budget, we get the cost baseline. And when we develop schedule, we will get schedule baseline. So that pattern we have already discussed. Along with this, you will also get a few things like, can you see project schedule in the project documents? Obviously, schedule baseline you see on the left side inside PMP. But what about project schedule? This also you will see in the project documents. You also see schedule data. These are some additional data related to schedule. And what else? There is one more thing, project calendars. Do you see all these in the project documents? What do you think? These three, 1, 2, 3. And this one you will see in the PMP, schedule baseline. Is it there? Found it? Okay, these three things in the project documents, project schedule, schedule data, and project calendar, and schedule baseline inside the PMP. This is what we get. And control schedule that you have here, this process. This control schedule will help you in managing changes to schedule baseline. And the output of control schedule, you already know, it is schedule forecast. When you monitor and control, you can forecast. Just like output of control cost was cost forecast, output of control schedule will be schedule forecast. So this is what we are going to get in this knowledge area. Okay, so let's start with this. We'll start with the very first process, which is plan schedule management, which we already know what we are going to get here. So let's see. Plan schedule management. In this process, we are going to develop a schedule management plan where all the guidelines, rules, and stuff will be there. So plan schedule management is the process of establishing the policies, procedures, and documentation for planning, developing, managing, executing, and controlling the project schedule. And benefit will be that this particular process, the benefit of this process will be that it provides guidance and direction on how the project schedule will be managed throughout the project. So again, as we discussed earlier, this is all about guidance, the rules of schedule management. And what you get the schedule management plan. Where does it go? It goes into the PMP, project management plan. Do we have something that we can refer to for this? We have this book of forms. Maybe this one we can check if they have this plan. Do they have this plan? Change management, scope statement, schedule management plan, right? So I've already shared with you the templates, but this also you can check out. Schedule management plan, you can see project title, date. I think this is even better than templates, right? This is something really that gives you exactly what you need into the plan. So this book of forms is very useful, I think. Schedule updates, reporting form, all the rules you'll put here in the schedule management plan. Moving forward to the next thing. So let's look into the schedule management plan itself, like what it consists of. Yeah, so it says schedule management plan is a component of the project management plan that establishes the criteria and the activities for developing, monitoring, and controlling the schedule. It could be formal, informal, highly detailed, broadly framed, and you saw that in the template that I showed you just now in the book of forms. These are the components of schedule management plan, and I think it's very similar to the cost management plan that we have already discussed. So schedule model development, like what scheduling methodology are you going to use? Something like critical path method, or what scheduling tool are you using, like Microsoft Project, Primavera, P6, or anything like that. Release and iteration length, if you're using Agile or Scrum, release and iteration length you can mention here. Those are the rules related to Agile. Level of accuracy, unit of measure, WBS links, again, the control accounts, schedule model maintenance, like how the schedule or progress in the schedule will be updated and recorded. Control threshold. Threshold is something that you see here as well. I think everything you see here, you can see variance threshold. What is this threshold? In Primavera P6 also, you can set up this threshold actually. There also you have this threshold thing. So what is this threshold? Threshold means, see, if there is a very little variation, it's not like you will be in a panic mode and you will start taking actions, you'll start making changes here and there. Sorry. If the variation is small, if the variation is very small, then you're not going to take any action. It's fine, it's under your limits. But if the variation crosses a particular threshold that you have initially set up, because this is what you do initially, this is planning, right? So initially during planning, you will set up a threshold that if my variation exceeds this particular value, then I'm going to take some action. Otherwise, I'll be fine. So it's like 5% variation or whatever it is. So variance thresholds for monitoring schedule performance may be specified to indicate an agreed upon amount of variation to be allowed before some action needs to be taken. I think I showed you this in Primavera P6 as well. In Primavera P6 also, you can set up these threshold values very easily. So I would say that's the one software which is very similar to the PMBOK processes. Primavera P6, I would say. I'll share with you the software as well if you need. You can let me know later on. I'll share with you the software. You can try to see if it works for you or not. Rules of performance measurement. So EVM rules you can mention here. So when we learn EVM, earned value management, you'll get to know what these rules are and all, and reporting formats. All these you can put here. And you can see that here also. This is your schedule management plan. All right, so let's move on to the next process, which is define activities. And let's see what do we have in the PowerPoint. So in the PowerPoint also, it will talk about the three things that we need before we start schedule management. Before we not start schedule management, before we develop schedule. Okay, so you cannot develop schedule until you get three things. You know those three things? First, list of activities, how the activities are related to each other. Third, duration of each activity, right? So activity list, sequence or network diagram, and then duration. If you have these three, see, if I have these three information, I can just put them into P6 or Microsoft Project or any other software and just click on a button and it will calculate itself and schedule it. And I'll get the whole schedule. I'll know the critical activities, non-critical activities and stuff. So this is how it works. So that's what it will show in the introduction as well. It says the project schedule in its most basic form is simply a representation of how long a project takes to complete. Right? So any project schedule is just a representation of how long your project is taking in terms of number of days, or maybe how the activities are related to each other in that schedule, how the project is really spread over time. That's what it shows. It includes a number of components. So you can see three components it includes, including activities that will be performed. That means activity list to execute the project scope, duration of each activity, that means duration estimates, and how the activities are related to each other. What is that? That is network diagram, how the activities are related to each other. That will be shown by a network diagram. Let's move on. So this is what we have to create ultimately, the project schedule. So project schedule is simply an output of any schedule model. So a Gantt chart could be a project schedule. Let's say you have created a timetable for what you are going to do next week. So that timetable is also a project schedule. You can consider that as a baseline, right? A timetable can have just one column where you have mentioned all the activities and another column where you have mentioned the date and time, start date, finish date, or something. Even duration you can mention there. Or maybe there you can add one more column where you have mentioned some relationship. So that is also your schedule. It's just a different representation of your schedule, maybe in a tabular form. So we are not saying that it always has to be a Gantt chart or a network diagram to prepare a schedule. It could be a table as well. So it says an output of a schedule model that presents linked activities with planned dates, durations, milestones, and resources. Right. So that's what project schedule is. And these are the things it includes. You can see includes starting and finishing activities on specific days and in a certain sequence. So every schedule shows the sequence as well. Plan dates for meeting project milestones, coordinates activities to form a master plan, tracks schedule performance. So you can track your schedule performance using the project schedule. So they have mentioned some points about project schedule, how how you can use it and stuff. Uh, Obviously, benchmarks and historical data can also help you in developing the schedule. What is benchmarking? I think we talked about benchmarking earlier. It simply means comparing. Benchmarking means comparing so that you would know where you stand and how well or bad you're doing. So benchmarking in case of scheduling would be like you will benchmark your schedule. That means you will compare your schedule with the schedule of some other product or service which is produced somewhere else in some other project, maybe inside your organization, outside your organization, it depends. Through benchmarks, you will assess the feasibility of a project, like whether the schedule is feasible or not, whether it makes sense or not, because you have created a schedule of a project and it takes like 1.5 years to complete that project as per your schedule. But somewhere else you saw another schedule of the similar kind of product or service and it took just 1 year. So now that means there is some problem in your schedule. It's totally off. It's not really similar to the benchmark. So again, comparing your schedule with schedule of some other project really helps you to, because the whole schedule is based on assumption, assumption that this is how your project is going to happen. It has not actually happened, but you're just assuming that it will happen. So there could be a huge mistake in developing schedule as well in your assumptions. You could have assumed a lot of things which are not really which don't happen, or you might have not assumed a lot of other things. So lots of things you need to consider when you develop a schedule, and it can be totally off from how it will actually happen. That's why comparing could really help, and that's what benchmarking is. And yeah, so sometimes when the work starts, you see that okay, you have totally underestimated the schedule or overestimated the schedule. These kinds of problems you might find. And historical data, of course, it gives you a starting point. When you have some historical data, you get a starting point. And if you're wondering from where you are going to get the historical data, I hope you all are aware of OPA, organizational process assets, where we have all the repositories and everything, right? So that's where we are going to get the historical data. Now, schedule management plan, we just now saw the schedule management plan only. It's a component of project or program management plan that establishes the criteria and activities for developing, monitoring, and controlling the schedule. So this we have already seen just now in the PMBOK, and these are the components of the schedule management plan. And these components, you can see these are mentioned in the notes as well. In the notes, you'll find a lot of things useful. Now, schedule management considerations for agile or adaptive environment. So we have two kinds of approach in agile. Do you know these approaches? One is the iterative scheduling with backlog. Another is on-demand scheduling. What is this iterative scheduling with backlog? This is your which one is Scrum? Which one is Kanban out of these? One is iterative scheduling with a backlog. Another is on-demand scheduling. So, the first one is Kanban, and second one on-demand scheduling. Where do you see iterations? Do you see that in Kanban or Scrum? Scrum. So it says iterative scheduling with a backlog. So can we say this is Scrum, right? Because it says iterative scheduling, right? So iterations are there. And this is on demand. So this is Kanban based on the demand. Remember, in Kanban, we focus on the demand. If there is a demand, then only we add item, right? So rather than supply, we focus on demand. So that's why it says on demand scheduling, right? So iterative scheduling with backlog is Scrum. And you can see if you read these, you will see where property is very similar to Scrum only. It says progressive elaboration uses a specific time window, often 2 weeks. What is this time window? It's the sprint, right? This is sprint, often 2 weeks. Requirements defined in user stories. Stories are prioritized. We talked about various prioritization techniques selected based on priority and time box. Remaining stories added to backlog, constructed later based on priority, delivers business value early and incrementally. All these properties we already know about Scrum. Allows changes during the entire project, and obviously Scrum or Kanban doesn't work well when there are complex dependency relationship. Remember that, because whenever there are complex dependencies, you do not get that agility that you need. So that's why it doesn't work when there are too many complex dependencies. Like construction of building has a lot of complex dependencies. You cannot construct fifth floor before you construct the fourth floor, right? You have to first construct the fourth floor, then only you can construct the fifth floor. It's not like if fifth story of the building is the priority, then you can start fifth story first. No, you have to follow the dependency. So in that case, Scrum is not going to work. That's why we don't use Scrum there. in construction of building and other stuff. Right? So that's an important point, that it doesn't work well when there are complex dependency relationships. Not only true for Scrum, it's also true for Kanban. And you can see that here. On-demand scheduling does not use traditional schedules. Team members pull work from a queue when available. So it's based on pull system, based on Kanban and lean methodologies, provides incremental business value, and levels out work of team members. Works best when activities can be divided into equal amounts. That's why it's more useful in manufacturing processes, production, and all. That's where it started. Does not work well when there are complex dependencies. So this is also true. We just now talked about this, that how difficult it becomes when you have complex dependency relationships. Guidelines to develop a schedule management plan. So these are guidelines. Guidelines means the inputs, tools and techniques, and outputs. There it is. So you can see the inputs, tools and techniques, and outputs. So here we have inputs means review. All these review that you see here, these are inputs. So project management plan, project charter, EEF, OPA, all these are inputs. You can see project charter, PMP, EEF, OPA. What are the tools and techniques? Use tools and techniques like expert judgment, historical information. That's what they have mentioned here. Meetings is also mentioned. When it says document, it means output. So what's the output? The schedule management plan for the project, right? So it really reflects the PMBOK itself. Now, the next process that we have is define activities. After we get the schedule management plan, now it's time to define the activities. So let's see. Define activities. So how are we going to get the activities? We are going to use another technique, which is very similar to a technique that we have used earlier. Remember, we broke down the scope statement into WBS, and we got the work packages at the last level of the WBS. How are we going to get the activities now from the WBS? Are we going to break down the WBS even further to get the activity list, right? That's why you see decomposition here. Right? The same tools and techniques you saw in that create WBS process as well, where you were breaking down the scope statement into WBS, where you got the scope baseline. Now it's time to break down the work packages, the lowest level of WBS. I'll show you that work package thing. Yeah, it's very subjective. That's why there can't be a guideline here, because totally depends on your field, on your projects, and it is something that usually comes with experience. You will initially make mistakes. Maybe you have broken it down to very high level. Sometimes you have not gone to detail, but ultimately you will find a time when, see, it has to be a package of work. Like painting is a package of work, right? It's not an activity, because inside painting you have to do a number of activities to complete the painting work. It's a package which can be scheduled, budgeted, and you can even assign to some person that this package is yours. It's like a group of work, group of activities. If you consider it that way, then I think it would make sense. But there's no particular rule. There might be a few guidelines in the PMBOK related to that, but not any rule that till what level you have to do that. And we'll see if there is any. And you can see this is what we did earlier. We broke down, this is our project scope, renovation of residential building. We had broken it down into exterior renovation, interior renovation. Exterior renovation was broken down into landscaping, painting. Interior renovation was broken down into flooring and interior decor. Now, we got the work packages. This was before we got the scope baseline, WBS and stuff. Now it's time to get the activities. Now, how do we get activities? We break down the work packages even more. So you need to break down landscaping. and you will get the activities. Okay, and if you want to look for decomposition, you can actually look into this book of tools and techniques, and there you will find this decomposition as well. Let's see if they have it or not. I'm not sure whether they have this decomposition thing here, but we might find it. Where is that? Maybe it's not there. But PMBOK has mentioned decomposition. No, it doesn't have decomposition. So decomposition again is very subjective in nature, like till what level you're breaking down. We'll see this in the PMBOK. But the point here is that earlier you decomposed the project scope statement into WBS and you got the scope baseline. Does everyone remember what do we have inside scope baseline? We have three things: scope statement, project scope statement, then WBS, then WBS dictionary. What do we have inside cost baseline? Just one thing: time, phase, project budget, excluding any management reserve. I hope all of you remember these baselines. And this is something that you need to remember, right? So the third baseline we are going to get today, which is schedule baseline. And that is just a schedule model. You don't have to remember anything. It's just schedule model. That itself is a baseline. So we'll see the definition as well. So define activities is the process of identifying and documenting the specific actions to be performed. Remember that activities are actions, action items. Like these are something that you actually do. This is how you can understand what activities are. That this is something that you actually do. Everything else, if you think about it, everything else is on paper. You don't do that. Like all these green boxes that you see, these WBS, that's just on paper. The whole project is just on paper. That's it. But what do you see happening around when you visit a project site? You see these activities happening, right? So whenever you go to a project site, you see activities happen. That's it, nothing else. You don't see people doing work package. Work packages cannot be done, right? Work package is just a collection of work, various works. So when you complete a certain number of work, then your work package gets completed, right? So work package is a group of activities. So work package cannot be done. Deliverable cannot be done. Planning package cannot be done. Control accounts cannot be done. Project cannot be done. It's not an action item. So it's just on paper. These are all made up items. We make up these items. We make these items on paper just to visualize the whole project, just to make it easier for ourselves to understand the project. We could have just listed a number of activities that we need to do, and we could have done it. We could have called the whole project as a number of activities. But just to have a structured form of data and a structured form of management, we create these hypothetical things like projects, deliverables, work packages. Till now, we have discussed that what is a project, what is deliverable, work package, planning package, control accounts. Actually, all these are just things on paper. This is not something that you do. But what you really do are the activities. These are the action items. These are not just on paper. These are something that you end up doing as well. So what happens is when you complete a number of activities, you complete a work package. When you complete a number of work packages, you complete a deliverable. When you complete all the deliverables, you complete the whole project. Okay, and that's how it happens. And why do we do something like this? Because that's how we figure out the activities. We start from the top, like what is our project? Okay, this is our project. Let's break it down. Okay, so now these are our WBS work packets. Let's break it down further. Then you get the activity list. Now you start doing activities in your execution, and then your project also gets completed. So when we plan, we plan it from top to down. That means first we figure out what the project is, then we break it down, 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 down. We reach the lowest level. When we start doing the work, it is done from the lowest level. That means activities. You do the activities, you complete work packages, you complete deliverables and all. So bottom up approach. So that's how we really complete the whole cycle. We start from top, we reach the bottom, we complete all the bottom items, that means activities. Then we accumulate all these, we roll them up and we get the whole project done. So that's how it happens actually. You start from here, you go down, you figure these activities, then you go up and you have completed the project. Okay, so that's how you should really look at a project. It's just a number of activities that you're doing. And that's why when I ask what is a project, many people really answer this only, that it's a collection of activities. It's a number of activities that you need to complete certain work. Although that definition is not a correct definition for a project, but still that is one of the things that you do in a project, right? So to get the activities, you need to break down the work package. So for landscaping, if I have to break down landscaping, I need to know how landscaping is done. So that's why, see, decomposition is a technique where you break down your packages. That's fine. But you need to have knowledge of that domain. If you don't have the knowledge of the domain, you cannot do decomposition. So you need some level of expert judgment as well. So if I'm not experienced in this field, in renovation of residential building or civil related, construction related things, then I would not be able to figure out the activities under landscaping. Like what are the activities, right? So you have to be experienced enough to get the WBS. So WBS, I would say, is one of the things where you need experience. You don't need experience to develop the schedule. Once you have the activities, once you have the relationship and the duration of each activity, you can develop the schedule. So developing schedule is not really a big deal. That's the easiest thing, I would say. Anyone can develop a schedule if you have all these three information ready with you. If you have the list of activities, duration and relationship sequence ready with you, anyone can develop a schedule. Someone who is in high school can also develop a schedule if they have these three information. But your experience doesn't comes handy when you develop a schedule. It comes handy when you identify other things which you need to know before you develop a schedule, like activity list, like estimating duration, like sequencing. These are the difficult things. These are the things where you need your experience. After that, after you have identified these three things, then it's very easy. So you don't really need a very experienced person to help you develop a schedule. Anyone can do that. But all the information that you need before you start developing the schedule, before you put them into software and all, is is the most you can say time consuming uh, and the most complicated task, because that's where you need your experience, right? Their skills won't be useful. How well you are with that particular field, like how many projects you have dealt there, what kind of situations you have seen. So that's where your experience will come handy in these processes. Define activities, sequence activities, and estimate duration in these. But when it comes to developing schedule, it's very easy, right? So define activities, what do? We break it down. We break down the work packages into smaller pieces, smaller activities. So it says define activities is the process of identifying and documenting the specific actions to be performed to produce the project deliverables. So these are the specific actions that you need to perform to produce deliverables. Benefit is that it decomposes work packages, like we were discussing, into schedule activities that provide a basis for estimating, scheduling, executing, monitoring, and controlling the project work. So without identifying activities, none of these could happen. You cannot do estimation, you cannot do scheduling, you cannot do executing, monitoring, and controlling. Nothing can happen. So you need to identify these activities. And how do we do that? We break down. What are we breaking down here? What do you think? It's fine that we are using decomposition. That's fine. We are getting the activity list, attributes, milestones. It's fine. But what are we really decomposing? What is there in the input that you're decomposing? What do you think? Where do you see anything there in the inputs? You're decomposing something there in the inputs. What is that? Scope baseline, right? Because scope baseline only has the WBS, right? Remember, scope baseline has scope statement, WBS, and WBS dictionary. So that's what you are decomposing. You're decomposing WBS, one element of WBS, which are the work packages. That's why you need scope baseline there. And schedule management plan will give you all the rules and stuff. So rules you will get from there. So you get the activity list. Ultimately, these activity list attributes and milestones goes into project documents, which you have on page 126. And you get this activity list. It includes schedule activities required on the project. Okay. And if you're using rolling wave planning means something that will be happening sooner that you're going to, for that you are going to find more details, and something that will be happening later that you will keep at high level. We discussed about rolling wave planning, if you remember, progressive elaboration. So that is kind of rolling wave planning mode. So in that case, activity list will be updated periodically as the project progresses. Like, you know what is going to happen next week or next to next week. You have the activity list for that. But for the fourth week from now or third week from now, you don't have the activity list. You have kept things at high level, right? So as the right time comes, you are going to decompose the work package there as well for that week, and you're going to get the activity list. So that's what rolling wave planning is, right? So periodically, it will be updated, the activity list. And attributes also, you can have some additional information along with that, milestones. So these things you're going to see in the PowerPoint as well. So I'll just use the PowerPoint for that. Project activities are distinct scheduled portion of work performed during the course of a project. And here they have mentioned that work package is the lowest level of WBS, and activity is a smaller component of a decomposed work package. That means when you break down the work package, you get the activities. So activity is a smaller component of decomposed work package. And task, you should not use the term task, first of all. Always prefer using the term activity. Although both of these are same, why people use task is simply because Microsoft project uses the term task. So that is one reason why people use the term task. But technically, you should go with activities. Also, although activities and tasks, these are same thing. But yeah, in some software like Microsoft project, you will find they're calling it as task. Primavera P6 uses the term activities only. As I said, it's very similar to what PMBOK is talking about. Features, so in Agile, we have something called features. There we don't have activities. You can have activities there as well if you break down the user stories about. So any functionality you can, put into a feature. It could be activity or effort like decomposition, bug fixes, testing, quality defect repair. So this is related to Agile. In Agile, we talk in terms of features. Delivers the capability that can be estimated, tracked, and managed as a set. Scheduling aligned to features ensure associated work is coordinated. Estimating features offer a view of when blocks of functionality can be released. And progress can be measured based on features that have been accepted compared to features remaining. So it's more like user stories only. So user story was one way of saying activities in Agile. So in Agile, it was more like user stories or features, you can say. User stories and features, they are the same thing actually. So in Agile, we use user stories. What we have activities here in traditional projects. In Agile, we have something called user stories. Uh, Now we also have milestones. That's another output here, milestone list. So milestones are a specific point in time. Like start of this training was a milestone. End of this training will be a milestone. So milestones are specific point in time. And why do we have these milestones? See, milestones, obviously, it will be useful for your top management, because your top management, your sponsors, they don't really care much about uh, the activities. I mean, they don't go to that detail level. They don't really want to see the status of activities and all. They don't have that much time to really look into that. They have other work as well, business related. So they won't be going into that much detail, but they want to know maybe how many milestones have been completed, how many milestones are left. They usually take the update in terms of milestones. So it's useful for communicating with the top management, milestones. But within the team also, milestones could be useful because, for psychological reasons, because milestones gives you a feel of accomplishment or a feel of progress. Like you can track your progress, like 5 milestones have been completed, 6 more milestones are left, something like that. So it just keeps the team motivated that, okay, well, we are, when we are doing some work, we are getting things completed, we are reaching a milestone. So milestone really helps to you can say motivate the team to some level, to once they achieve one milestone, they go for the next milestone. Just a way to measure their progress as well. So it's useful not only for top management but also for the team. So having milestones is good. It's just a point in time. Remember, it's not a duration. Milestones do not have duration. Activities have duration. Milestones can have just start date maybe or end date. They cannot have both start date and end date, different start and different end date. No. Guidelines, finally, guidelines means where's the guideline? Guidelines means this inputs, tools and techniques, and outputs. So review means all the inputs, schedule management plans, scope baseline, EEF, OPA. Tools and techniques, we have decomposition. So it says analyze and decompose each work package of WBS into activities that will be required to produce the deliverables. Consult SMEs. SMEs means expert judgment. Expert judgment includes consultants, SMEs, and all. Evaluate all constraints and assumptions. And then we have, once you have decomposed each work package into activities, evaluate your activity list. That's an output, activity list. So now they have given one activity here, one scenario they have given, and they are asking you to find out the milestones and activity list. So if this scenario is not relevant to your domain, this is somewhat related to construction. So if it is not related to your domain, you don't need to do it. It's fine. You can just look at it as an example. These milestones have been identified. If it's relevant to your domain, you can check it out. And activity list also, you can see these are the activities. So if it's relevant to your domain, you can try this. Otherwise, take it as an example. Just see what they've done. They've just listed the activities. And again, this is subjective. It's not something, it won't be asked in the exam. Obviously, PMI cannot ask you anything related to one particular industry, because if you're not from construction industry, you would not be able to understand this. And they can't ask you any question related to IT industry either if you are from construction industry. So yeah, they might give you some generic activities if they want to give any question, some generic, something that you see on day-to-day basis. day-to-day life. So that might be there, but nothing related to any particular industry. I don't think they would do that. So moving forward to the next process. So we got the activity list, right? And if you want to see how an activity list look like, you can just check these forms. And in the form, we have this activity list. This is how it looks like. You can see ID, activity, description of work. And if you're wondering what is activity attributes, here you can have some additional details of the, just like we had, remember we had WBS dictionary. Just like that, we have this activity attributes as well, where you can have all the additional details of activities, which will obviously get, you know, completed as you move forward in your project. It's not like initially only you will have this. So you can see ID, activity, description of work, right? Then you have predecessor, relationship, lead lag, successor, relationship, lead lag, and all. Okay. Skills requirement, required resources, type of effort, and all. It's like an attribute page. So for each activity, you can have an activity attribute. Location of performance, imposed dates or other constraints, assumptions, type of effort, some additional details, right? It is something that will get updated over the period of time. It's not that you'll get this initially done. Milestone list, this is how it looks like. Milestones, milestone description and type. I would also add ID, because IDing we do in milestones as well. They have not mentioned ID. ID is really important. Next is this network diagram. That's what we are going to get next when we do this particular activity. So after define activities, what's the next one? Sequence activities. So remember, we got activity list now. Okay, so how many things do we need to develop the schedule? We need two more things. We got the activity list. What else do we need? We need the duration, right? So we need to get the relationship between these activities and the duration of each of these activities. Then we can say we would be in a position to develop the schedule, right? So this is where, this is sequence activities. This is where we are going to get the relationships, okay? And when we get the relationships, that means we are going to get the links between these activities, and we are going to get this project schedule network diagrams. That's the output. So what does it say? Sequence activities. Because, you know, why do we need this process? Because let's say there are 10 activities, but it's not like all these 10 activities will be happening all at once. All of them will not be starting at once and ending at once. There will be some dependency, right? Because you can't really do one activity before you complete some other activity. There is always some dependency, right? Even in the work that we do throughout the day, in general also, right? It's like I cannot start, let's say, I'll give you one example. I cannot start the meeting until I start the computer. I need to open the computer, start the computer, then only I can start the meeting. So there is a relationship, right? I can't just have this start meeting activity anytime sooner than start the computer. I need to first start the computer, then only I can start the meeting. So that's one relationship right there. I cannot close the computer, close the laptop until I stop the meeting. So there is always a relationship everywhere. There is a relationship between the activities that we do, right? And this we see on a daily basis as well. So we are going to talk about various relationships here. All right, so it says sequence activities is the process of identifying and documenting relationships among the project activities. The key benefit of this process is that it defines logical sequence of work to obtain greatest efficiency, because there is certain relationship that if you follow that, it will provide you the greatest efficiency. That means you'll be saving time and money if you do the activities in certain sequence. That is something that you need to find out, and that really comes from experience, right? Greatest efficiency given all project constraints. So this is the process. So let's figure out the things here. Ultimately, what are we going to get? We are going to get this, right? Project schedule network diagram. What do we need in the input? We need the activity list. Without activity list, you cannot create a network diagram. You cannot have the relationships and stuff. You cannot know what's the relationship if you don't know the activity list. You need to know the activity list, maybe attributes as well, you know. Scope baseline also can help you, and obviously schedule management plan is there for the rules and guidelines. Okay. What is the tools and techniques that we are using? Precedence diagramming method, and this is also another one, dependency and determination. If you're wondering what is this PMIS, PMIS means the software tools that you're using. Any software tool that you're using, let's say Microsoft Project, Primavera P6, Jira, Excel, anything that you use for managing your project. That comes under project management information system. Wherever in the tools and techniques you see this project management information system, I call it as PMIS. It simply means any software tool that you're using. Microsoft Project, Primavera P6, Microsoft Excel, anything, right? So, and it's true, we take the help of software to really develop a network diagram, right? But you need to figure out the relationship yourself. A software cannot tell you the relationship. Yeah, once you know the relationships, a software can help you arrange these relationships together and create a network diagram. That is how software would be useful. So when you sequence activities, you get this project schedule network diagram, which goes into project documents. Then, yeah, let's talk about these relationships now. So we'll be using one technique. We'll be discussing about one technique, which is called this precedence diagramming method, PDM. So let's talk about that. Here they've mentioned the precedence diagramming method, PDM, is a technique used for constructing a schedule model in which activities are represented by nodes and are graphically linked by one or more logical relationships to show the sequence in which the activities are to be performed. So that's what we are going to learn. And I hope you have heard of these things like predecessor, successor. Even if not, it's fine. We will discuss it. I'll not this. So let me give you an example of that. Okay, we'll talk about relationships now, relationship between the activities. Okay, so what is the difference between predecessor and successor? What do you think? Let's say right now I'm delivering this training. So right now I'm into this activity, training. And after this, I have to go for grocery shopping. I need to buy a few groceries. So which one is successor, which one is predecessor, and why? Mhm. Right. And grocery shopping, you're saying that is successor. Right. And so let's say uh, let's say another example I'll give you is, let's see few things. Yeah, grocery shopping is successor. But let's say after this training, I don't have any work, any particular work. So I'll just go for walk, evening walk. So is that a successor? Like, it's not something, how do I tell you? Like, there is a condition why successor is successor. Remember that successor is a successor. Oh, okay, let me ask you this question. Why are you saying that grocery shopping is a successor? Why grocery shopping is a successor to trading? Any activity that I do after this training will be a successor, are you saying? Or any activity that I did before this training is a predecessor of this training? Um, right, right. But what if there is no relationship? In this case, in the groceries shopping case, how is there a relationship? What do you think? How would you prove that there is a relationship? Uh, Maybe I'm just going to grocery shopping because I can do any other work, but I went to grocery shopping. Maybe. Don't you think relationship will exist only if I say that I cannot start grocery shopping until I finish the trading, right? So there is a relationship only if you're saying like this, that grocery shopping is dependent on training. If I finish this training late, I'll start the grocery shopping late. If I finish this training early, I'll start the grocery shopping early. So there is a dependency. Remember, there has to be a dependency. So which is dependent on what? Is the training dependent on grocery shopping or grocery shopping dependent on training? The second one, the grocery shopping is dependent on training. Is that the reason why grocery shopping is a successor? Because it's a dependent activity, right? So that's the answer. A successor is always a dependent activity. Remember, successor is a dependent activity, and on which activity it is dependent? It's dependent on the predecessor. Predecessor, on the other hand, is an independent activity. This training is an independent activity. If this training takes more time, it doesn't matter. It's not really dependent on anything. Uh, but the grocery shopping, if training gets delayed, grocery shopping will also start late. If training finishes early, grocery shopping will start early, right? So it's totally dependent on the training itself. So whenever there is dependency, that's when you can call anything as a successor, right? So remember, everyone, that successor is always dependent on predecessor. Predecessor, on the other hand, is an independent activity. That's the only reason we call them as successor or predecessor. And you should not say that this is not how you should define successor. Like, successor is an activity which comes after predecessor. Predecessor is an activity which comes before successor, because this is fine. Yeah, this happens, but it's not necessary. And like, I'm randomly doing two activities one after the other. I can't call the other activity. Like, let's say right now I'm reading a book, and next thing I'm doing is I'm eating something. So it's not that these two are dependent. Like, I cannot eat anything until I finish reading the book. No, it's not a dependency, right? I'm randomly doing these two activities. They are not dependent on each other. But in this case, grocery shopping is totally dependent on the training. So once I finish the training, then only grocery shopping will start. So I hope this concept of predecessor and successor is clear, that successor is always a dependent activity and predecessor is an independent one. That's why you see here that B is looking at A, right? Why B is looking at A? Because B is dependent on A. B is the successor, right? So how many dependencies do you think we can have? Like, one dependency I can tell you is successor cannot start until predecessor finishes. Like the example I gave, grocery shopping cannot start until training finishes. Because when we say that successor is dependent on predecessor, we are just saying it as an activity. But don't you think it's not the successor which is dependent on predecessor? It might be the start of the successor or finish of the successor, dependent on start of the predecessor or finish of the predecessor, right? It cannot be an activity dependent on anything. I can't say that grocery shopping is dependent on training. That's not the right statement. It's not a complete statement, I should say. What's the complete statement? Start of grocery shopping is dependent on finish of training. That's a complete statement. So when you're talking about dependency, you should not just talk about activities. You should talk about what exactly are you saying, like start of it, finish of it, how they are related. So start of a successor can be dependent on finish of the predecessor. Finish of a successor can be dependent on finish of a predecessor. How many combinations can we create like this? There is predecessor, there is successor. Both of them can start or finish. Four combinations. That's correct. Because there are two activities, both of them can start or finish. And that's why four combinations. I'll show you all these combinations first. So let's say, see, this is our activity, let's say. This is our activity node. Okay. And remember, left side of the node represents start, right side, finish. Whenever you're creating a node on a network diagram, it's just a visual, network diagram is just a visual representation of your relationship between the activities. So how many combinations we can create? Four. The most common one being FS, finish to start. Then SS, then finish to finish, FS. Then the rarest of all, SF. Let's talk about these relationships now. Okay, first of all, let's talk about the most common one, which is finish to start. What we are learning right now, if you're wondering what we are learning right now, we are learning precedence diagramming method, PDM. Right? Using this method, we create the links between the activities, the relationship links. Okay, finish to start. F, S. So just put FS here. Now, F is towards which activity? Predecessor, that means A, and S is towards B, right? So that you can clearly see that F is towards A, S is towards B. I don't even have to show you this. I just remove this, right? So that's clearly visible to you. That F is towards A, S is towards B. So what will be finishing and what will be starting? Right, because F is towards A, so A will be finishing and B will be starting. So if A is finishing, on which side the link will start? Left side or right side? Right side, because right side represents finish. For any activity, right side node will be finished, left side of the node will be start. So I'll put one dot on the right side of A because that's finishing. One dot on the left side of B because B is starting. And what shall I do now? Just connect these dots. Where will the arrowhead be pointing? Towards successor or towards predecessor? The arrowhead. When you're creating a link, the arrowhead should be pointing towards the successor or successor, right? It should be pointing towards successor or the dependent activity. So this is how it looks like, right? And that's the reason why, have you seen that in flowcharts that you create? In flowcharts, this kind of arrow is used. Why? Because in most of the flowcharts, this relationship is used. You can't start the next process until you finish the previous process. I think all of you might have seen that in flowcharts and stuff. So that's why we see this link. This is finish to start link. And what's the statement that we are going to use? Let me put the statement as well. Statement would be like we cannot. What shall I put? Sometimes people call it B should start after A finishes. Is that what we should call it? B should start after A finishes. So what I'm asking is it necessary that B has to start as soon as A has finished? Is that the relationship? Like if I'm saying that grocery shopping, like do you think B should start as soon as A has finished, or is it necessary? Like I have finished the training. Obviously, the grocery shopping is dependent on training, start of grocery shopping. So let's say training finishes at 5 p.m. It has finished at 5 p.m. Will I start grocery shopping exactly at 5 p.m.? What's the condition there? What's the relationship this about? Is it saying that I need to start my successor as soon as the predecessor has finished? Or is it saying that what I don't have to do? What I don't have to do here is I don't have to start my successor before the predecessor finishes. So it's talking about what not to do or what to do, this relationship. What do you think? Because if you're saying that the successor should start once predecessor finishes, that means I need to just, as soon as I finish training, I have to start the grocery shop. What do you think? Don't you think it's talking about what not to do? Like you cannot start successor until you finish the predecessor, right? So the right statement should not be B should start after A. No, that's incorrect. People usually call it, they make a mistake. When you're calling it that B should start after A, that's a mistake you're making for this statement. Many people call it that way. But what should be the correct statement? B cannot start. B cannot start, not after A, but until A finishes. Don't you think this is a better statement than that? B cannot start until A finishes. That means you cannot start B until you have finished A. Once A has finished, then you can start B anytime you want. You have a float above, ahead of you, right? You can just start B wherever you want, whenever you want. But the condition is that you cannot start B until A has finished. Does that make sense to everyone? What this relationship is talking about? It doesn't talk about when you have to start. It just talks about when you don't have to start the successor. Makes sense to everyone? What do you think? You cannot start B until A finishes. Yeah, okay. So this is finish to start relationship. So I'm just saying that I cannot start grocery shopping until training finishes. And that's true. Do I have to start grocery shopping as soon as training finishes? No, it doesn't say that. It's not saying that. No, it's just saying that I cannot start grocery shopping until I finish training. Once I've finished training, I can start grocery shopping. It's fine, right? Because don't you think you are restricting yourself too much if you are saying that successor has to start after predecessor finishes? Because you are putting constraint there. That's a constraint actually, right? So in this case, it's more free, like you can start. But the only condition is you cannot start until A has finished. So that's finish to start relationship. Any example from your projects? I'll give you one example from from what I have seen in my experience. I'll give you one example on the chat. So all of you can put some example on the chat in the form of same statement. B cannot start until A finishes. That's how you have to put that example. So let me put something like, yeah, same thing. Grocery shopping. Grocery shopping. You can put your example on the chat. Let's see all the examples. Shopping cannot start until training finishes. Another one, I think in construction, we have something like column costing cannot start until column formwork finishes. So editing cannot start until shooting finishes. I agree with that, and I don't agree with that as well. Vishwanath, don't you think shooting and editing can happen parallelly as well? If it's a long shoot, if it's a very short shoot, then obviously you'll finish the shooting first, then you will start editing. Okay, but both of them can happen parallelly as well. So it would be more like editing cannot start until shooting starts. That would be a better, uh, you know, relationship. But yeah, totally depends in what context you're talking about. If it's a very small shoot, you should do the editing next. So Apply Nadu says after completion of village electrification, we can submit the handling over the same village. Yeah, so handling over the village cannot uh, uh, start until electrification has finished. Yeah, that makes sense. Uh, Others, any example from your projects? Others, you can put your examples on the chat. And this is the most common relationship that you will find. What do you think? Can you mention some example on the chat? You can speak as well, both ways. Uh, mhm. Okay, so checking the model or testing the model cannot start, or evaluation cannot start until the model is built. Yeah, right. That makes sense. So this is an example of finish to start. And remember, finish to start is the most common relationship. This is the most used relationship in the projects. Let's move to the next one now. After finish to start, a little rarer than this is start to start. Think of an example for start to start as well. Start thinking of it. Okay, so what is going to happen here? A is starting, B is also starting. So B start is dependent on A start. So which side should be connected to which side? Which side of A should be connected to which side of B? A is starting, B is also starting. Both on the left side, right? Because it is starting. So left side this, left side this. And now connect these arrows using a line like this. This, and this. This is start to start, you can see. And now I can just, make some changes in the statement. It says B cannot start until A finishes. So instead of finishes, I'll put start. Starts. So B cannot start until A starts. So that is start to start relationship. Example. Let me put some examples on the chat. You all can also put some examples. One example is, let's say, training cannot start until meeting, online meeting or Google meeting. Let's say Zoom meeting. Zoom meeting has started. Until Zoom meeting starts or has started, anything you can say. Yeah. So training cannot start until Zoom meeting starts. You all can also put some examples. I think that editing example will work now. Editing cannot start. So let's say you are one team is editing the document, another team is writing the document. So editing of document cannot start until writing of document starts. Any example from your side, anyone? I'll give you one more example related to construction, that pouring of concrete cannot, no, leveling of concrete cannot start until pouring of concrete starts. Because once you start pouring the concrete, you need to start leveling the concrete as well. So Vishwanath says timer cannot start until game starts. Yeah, that's also true. That is also correct. Any other example? It's a little rare than finish to start, which is the most common one. But yeah, in this one also, you will find various examples. Okay, so this was start to start. I hope this is clear. I have mentioned few examples. Next is finish to finish. F, F. Here both F, so both sides on the right side. Right side will be connected to right side. Let's connect them like this. This is finish to finish. And in the exam, they can just give you this link and can ask you which relationship is this. So if you know the logic, you'll be able to figure this out. Okay. Or they can give you the statement and they will ask you which of the following links is true. So B cannot finish. You can put your examples on the chat. I'll just finish this. B cannot finish until A finishes. I think the same examples that we took for start to start, we can take here as well. B cannot finish until A finishes. Let's see. That will be like Zoom meeting cannot finish until training finishes. Zoom meeting cannot finish until training finishes, right? What else? It would be like another one will be editing the document cannot finish until writing the documents finishes. Anyone putting any other example? I hope this makes sense. Whatever I've kept, like this might be not so common for your projects, but still, I hope the relationship is clear. So B cannot finish until A finishes. Let's move to the last one, the rarest of all, right? Let's look into that. So Krishna says cooking cannot finish until required taste and consistency reached. Yeah. Now here there is some problem that taste and consistency reached. How are you going to make sure that is reached? Through certain activity. So here you have not mentioned the activity. It's more of a condition, right? So that is one problem here. So cooking is an activity, that's fine. But taste and consistency reached, to make sure, that's a condition. So for that condition, what activity are you doing to check that condition? Can we say tasting, or maybe something like checking? Yeah, check finish. So cooking cannot finish until the check has finished. Check, or you can say testing the dish or something like that. Right, right, right. So we can call that activity as quality check or something. So cooking cannot finish until quality check has finished. So that is also true. That will also work. So now moving on to the last one. The last one is finish to sorry, start to finish. SF, start to finish. And here the left side of A will be connected to right side of B. It will be like this. This is finish, sorry, start to finish, the rarest of all. What does it say? It says that B cannot finish until A starts. Now you might be wondering that that's really a weird statement, and it's not possible or something. Yeah, it's rare. It's rare. That is true. But it's still, it is possible, because when this is used wherever you need some kind of a, let's say, consistency, or not consistency, I should say continuity. Yeah, continuity. So in case you want continuity, in your work, in your activities, continuity, or what do we call it, seamlessness, seamless interaction between your activities, then you can have this. I'll give you one example. So let's say you're using one internet subscription right now, and you want to change to some other subscription. So would you end the previous subscription first and then buy the new one? Or would you first buy the new one, then end the previous one? You will buy the new one and then you will end the previous one, right? So what relationship are you using there? You're using this relationship only. You're saying that uh, the previous subscription cannot finish until new subscription starts. Why are you doing that? Why are you using this relationship in that case? Do you want to maintain continuity in these two activities, right? Continuity or seamlessness, you can say. You don't need any, you need a seamless interaction between these two activities. Or let's say, yeah. Yeah, I mean, in this example, which one are you going to consider predecessor, which one successor? It totally depends on which one is dependent on what, not on the order, remember. Predecessor and successor is always based on which is dependent on what. So which is no, the new subscription that you're taking, that is dependent on the no, the previous subscription in this case is dependent on the new subscription, don't you think? The dependency has changed here because the previous subscription is dependent on the new subscription, or is it the other way around? Yeah, because you will not end the previous subscription until you have bought the new subscription. So don't you think the dependency now is different, that the previous subscription is dependent on the new subscription? So previous subscription is just waiting for the new subscription to be bought. That is what it is like. Yeah, somewhat like a relay race only. You can take that example, or it's like when people are working in shifts, right? So don't you think the previous shift is dependent on the next shift rather than next shift being dependent on the previous one? Because if you are in one shift, you will not end your shift until the new shift has started. Someone who will be replacing you, right? If you're doing some continuous work, let's say operational work, you need the next shift person to be there. Then only you can finish your shift, because then who will be there? If you just, let's say your shift ends at 9 p.m. and the new person shift begins at 9 p.m. And if the new person hasn't arrived at 9 p.m., would you leave your place there? You would not leave, right? You will wait for the person to arrive. So that means your shift is dependent on, the end of your shift is dependent on the start of the next person's shift, right? So here the dependency is different. The successor in this case is your shift, and the predecessor is the other shift that is coming. So that's little confusing, this one, but still this makes sense. I think this is where you want to maintain continuity, and this is the most, you can say, rarest of the relationships, but still it's not that it doesn't have any application. It has application. You can use it whenever you need this kind of continuity, that you cannot finish a particular work until you start the other work. Okay, and I gave you example of this internet connection subscription, and also shifts, the shift job, whether it is a job of security guards where they have, let's say a security guard is working at a bank, and they're working in two shifts of 12 hours. So the previous shift cannot be finished until the new shift has begun, right? So this is start to finish, rare but still valid. I mean, still it is used in projects, but it's yeah, in projects it's not used. That is something that I should tell you. It's not used in projects. In projects, you will not find this kind of relationship, but still this relationship exists. This is something that is there on paper, it's there, but in real, whether it will be useful in projects or not totally depends on your projects. I think in IT projects this could be used, right? In IT projects you need something like this sometimes. You're working on servers and stuff, and you need to plug out something, and you need to first plug in something before you plug out something else, right? Otherwise your power source will be gone. Let's say you're doing some maintenance related stuff. So if you plug out some switch or something, you will lose the power. If you have to do some repair in that wire, you will plug it out, but you need to start some new power source before ending a previous power source. Don't you think this is one example in IT? Let's say if you want to remove a power source, don't you think you should start a new power source? In order to finish a particular power source, you have to start a new power source. So you need to plug in something else in order to plug out some wire, right? So that the power source is always there. It gets the power from some. Otherwise, that's the reason. Otherwise, your customers will see some disruption in the software, in the application they're using, right? So that's dependency, and four types of dependencies we have discussed, and that's what precedence relationships are. So you can see an activity dependency is a logical relationship that exists between two project activities. And activity dependencies determine the precedence relationship. And this is something that we are going to talk about now. But before that, let me show you this precedence relationship that we just now discussed. A logical dependency used in the precedence diagramming methods. And these are the four relationships. It's also there in the PMBOK. You can see A to B. So in this case, B is the successor, the white box is the successor, the gray box is the predecessor. And look at the relationships: finish to start, start to start, finish to finish, start to finish. These are the four. And you can see the links as well. And if you want to look at some examples, they have these examples in the notes. Finish to start, finish to finish, start to start, start to finish. You can check these examples as well. Next, finally, the guidelines. But before guidelines, we need to check this one as well. So we talked about precedence diagramming method. Now we are talking about this. There was one more tools and technique, which was dependency and determination. Yeah, dependency, determination, and integration. You saw here in the tools and techniques, you have dependency, determination, and integration. So let's see what this is. So there are four kinds of dependencies. Actually, these are grouped into two categories. One category is based on mandatory and discretionary. Another is based on external and internal. So on two bases, they have been grouped. First of all, mandatory and discretionary. What are mandatory relationships or mandatory dependencies? By the term mandatory only, you would know what it is. Now forget about the precedence diagramming method that we are not discussing here. We're just discussing in general what it is. Mandatory means hard logic. That means you can do certain work in that sequence only. You can't do the other way around because it's not possible. Maybe because of contractual requirements, or maybe because it's inherent in the nature of the work. I'll give you one example. Can you build fifth floor before building the fourth floor? Don't you think that's a mandatory relationship? That you cannot build fifth floor of a building until you finish fourth floor, because you can't do the other way around. Is the opposite true? Is the opposite also possible in this case? No, right? You can't build the fourth floor first and then build the you can't build the fifth floor first and then build the fourth floor, right? So the other way around is not possible. Why? Is it because of contract? No, it's because of inherent in the nature of work. It's part of the nature of work. Sometimes it's because of contract as well, that you need to do this activity first, then this activity. That's mandatory relationship. Remember, mandatory relationships are hard logic. So you can't do the other way around. you can do in certain sequence only. Like I'll give you one more example. I cannot start the training until I start the Zoom meeting. So I need to start the training first. Sorry, I need to start the Zoom meeting first. Then only I can start the training. Can I do the other way around? That means start the training first and then start the Zoom meeting? No, it's not possible because it's in the nature of work itself. It's not mentioned in the contracts. It could have been mentioned in the contract as well, but it's not because of contract. For me, in this example, it's because of nature of work. There might be a few mandatory relationships based on contract as well. Can you give some example of mandatory relationships, anyone, that you deal with? I think this is something that you might be dealing with in your projects as well. There might be some mandatory relationships in between two activities, maybe because of the contract or because of the nature of work, because the nature of work doesn't allow you to do the other way around. You can do that in one sequence only. What is that? Can we say testing and developing? Testing of deliverable cannot be done until development has finished. What do you think? Any example, anyone? Any example of mandatory relationship that you deal with in your projects? So are you saying that there is no mandatory relationship in your projects? You can do any work in any sequence you want? Right. So you're not allowed to do few activities in other sequence. You can do in one sequence only, like you will do B after A only, because it's there in the policy, it's there in the contract, right? So in the policies or in the contracts also, things are mentioned. So that's mandatory or hard logic. So Purushottam is saying we cannot start the quality check until product completed. Right. So that's true. That is also a mandatory one. You can't to start the quality check. Is it because of contracts or nature of work? I think it's more of because of the contract, right? Purushottam. Yeah, correct. Because you can, I mean, practically you can start checking the product before it is completed, but due to the contracts, it's not something that you can do. I need to disconnect due to some family. Okay, hopefully the recordings will be there. Yeah, recordings will be there. Yeah, no problem. Okay, so that's Aplanadu says after completion of erection works been completed, then we can do the village electrification. Yeah, that's correct. So that's also. Is it because of nature of work or contracts? I think it's more based on nature of work, right? Billing cannot be done until work done, right? This is because of contracts, not nature of work. You can do billing even before work has been done. It's possible technically, but due to the contractual issues, contractual thing, you cannot do that, right? So it could be because of contracts, it could be because of nature of work. Any of these is possible. So that's mandatory relationship. What is discretionary? Mandatory means hard logic, discretionary means soft logic. Okay, so discretionary means you can do the other way around as well, but you're not doing it because it's more desirable to do certain work in certain sequence. Okay, so it's called soft logic, a relationship that is established based on knowledge of best practices within a particular application area or an aspect of project where a specific sequence is desired. That's discretionary. Discretion means choice. Discretion means choice, optional, right? That means you can do the other way around as well. You are doing B after A, but it's not that you can't do A after B. You could have done that way also. But since doing B after A is more preferable, more desirable than doing A after B. That's why you're doing in certain sequence. So that's soft logic or discretionary. You can do the other way around as well. Example, I'll give you a very common example of discretionary dependency. In the morning, usually what do? We first brush our teeth and then we go for bath. Is it mandatory or discretionary relationship? We first brush our teeth and then we go for bath. It's discretionary, right? So why? Because it's not like it's not like you cannot do the other way around. You can first take the bath and then you can brush your teeth as well. That is also possible. But why do we follow a certain sequence? We first brush our teeth and then take bath because it's more desirable. It's more desirable. Okay. So yeah, payment cannot be done until invoice received. We can do prepayment as well. Yeah, that is also true. But I think it's more, sometimes it's there in the contracts that you cannot do the payment until invoice is received. Sometimes it's mostly there in the contract. So it could be mandatory as well. So if it is in the contracts, then it is mandatory. If it is not in the contracts and there is an option to do some prepayment, then it's discretionary, so both ways it can work. Another example would be I think this example is fine. I think they have given a few examples here in the notes as well. I'll show you some example. Discretionary. They've given some nice example. Yeah, this one. No, in this one, they have not given any example. They are not necessary, can be modified as per a better sequence is found. Depending on application area, it might be there, but I'll just check if the PMBOK has an example or not. Maybe they will have this. Discretionary, they have given one example, maybe. I'll just check. For example, generally accepted best practices recommend that during construction, electrical work should start after finishing the plumbing work. Okay. So it's more desirable to start electrical work after finishing the plumbing work, but it's not like you can't do the electrical work first, then plumbing work. It's not necessary, right? So it's a soft logic. It's a discretionary dependency. Okay. So first we do the plumbing work, then we go for the electrical work. Usually, that's discretionary. That's optional. But it's not the other way. I mean, other way around is also possible in this. So that's a soft logic. That's a discretionary. Next is on another basis. It's not on the same basis. On one basis, it's mandatory and discretionary. On another basis, it is external and internal. External relationship means your project activities are dependent on non-project activities, or your project activities are dependent on external activities. Like start of your work is dependent on delivery of a material or resources. That's external relationship because it's not under the control of your project team. Your project team cannot control the delivery of materials. It's outside their control. So that's an external relationship. So project activities and non-project activities, that's external relationship. I cannot start work until some material is delivered. Okay, so that's an external relationship, and we don't want these kinds of relationships much, because then you have very less control on your projects. If you have too many non-project activities, you don't want them. So that's external relationship where your project activities are dependent on non-project activities, maybe delivery of parts or something like that. So that might induce some additional risks in your projects. Internal relationships are the most common one. Everything inside the control of your project team is internal relationship, internal dependencies happening, everything inside the project. So contingent on inputs within the project team's control. That's internal dependency. So external and internal, they might have given some example here. External, they have given this example, delivery of a part that is needed to build a prototype. So delivery of part is external, is a non-project activity. Internal, the software testing is dependent on software being written by software development team. Okay, that's totally internal. Okay. So these are the types of dependencies. Now, yeah. No, it's totally different. It's a different type of classification. One type of classification is mandatory and discretionary. Another type of classification is external, internal. These can overlap as well. That, like, yeah, one relationship could be mandatory and internal, both. Another relationship, but mandatory and discretionary cannot overlap. External and internal cannot overlap. That's mandatory and internal, both. Yeah, right. Yeah, it's a combination because these are two different classifications. So there are four combinations you can create: mandatory external, mandatory internal, discretionary external, and discretionary internal. So four combinations can be created. So in your experience, what do you think, all of you? What kind of relationship you have seen the most? I have seen mandatory internal the most. Yeah, mandatory internal, I think these are the most common ones. Uh, Discretionary also you might see, external also few of them, but MI, mandatory internal, is the most common one. Others can also answer. Which of these combinations have you seen the most in your projects? ME, MI, DE, DI. What do you think? You can mention on the chat. Which of these combinations have you seen the most, all of you? Mandatory external, mandatory internal, discretionary external, or discretionary internal? Sergio says mandatory internal. Purushottam also says mandatory internal. I think mandatory internal is the most common one that we see, but I would say in most of the agile projects, many things are discretionary. Their mandatories are very few. So because it works based on priority and it's a discretion, it's based on your discretion, based on your knowledge of best practices, you can choose which user story you're going to complete first and next, depending on priorities as well. But these priorities are set by you only, right? So that's based on the discretion. It's not mandatory, right? So mostly agile projects, you can say they could be discretionary dependencies, external or internal. But in construction projects or traditional projects, I would say mandatories are more common, mandatory and internal. So with this, we have completed this particular topic, and we will look at the output now, because output we have not generated yet. What's the output? The output is this project schedule network diagram. So I'll show you how to create this network diagram as well. But first, look at the guidelines. Guidelines to sequence project activities. Guidelines means these: inputs, tools and techniques, and outputs. So in inputs, we have this review. Review means inputs. Review. So schedule management plan, activity list, activity attributes, milestone list, project scope statement, EEF, OPA, all these are inputs, you can see. Use tools and techniques like PDM. PDM means precedence diagramming method. That's what we discussed, dependency determination and all. These are the tools and techniques. What's the output? Output means document. Whenever it says document, that means that's the output. Document is project schedule network diagram. So, but we didn't get any project schedule network diagram. They have given one example here. That's fine. This one. But we haven't really tried this. So let's try this. try one example. I already have an example that we can try. Leads and lags. Yeah, leads and lags, actually, they have not really mentioned in the PowerPoint. That's why I skipped that. But still, I would, since it's mentioned here in the guidelines, they've mentioned here leads and lags. Let's look into this as well. Okay, so leads and lags, we can discuss. It's something that you can put in software as well. I think Primavera P6 and Microsoft Project also has this thing, leads and lags. So let's discuss this as well. So let's say you have, first of all, let's discuss about lead. So lead, second. No, first let's discuss about lag. So lag simply means delay. So when you're inducing a delay in that. So let's say right now let's say there are two activities. A, which takes 3 days. No, 1 day. A takes just 1 day. And after that we have B. B takes 2 days. And the relationship is finish to start. But there is a lag of 2 days. Lag of 2 days, you can see. Finish to start plus 2. What does that mean? It means that, let's say this is Monday, Tuesday, Wednesday, Thursday, Friday. Saturday, Sunday is a holiday. So A will be happening on which day? Monday. Let's say it's starting on Monday. That's A. It's just 1 day. When will B start? There's a lag of 2 days. Lag means B cannot start until A finishes. That's fine. But plus 2 days. Yeah. So are you saying Thursday? Yeah. Right. So B will be starting on Thursday. And it will happen for 2 days, Thursday and Friday. That's B, right? So even though the relationship says B cannot start until A finishes, but there is a lag of 2 days. That means we are adding a delay. We are inducing this delay of 2 days. This relationship is like Fs plus 2. Okay, this is lag. On the other hand, lead means lead. Lead means head start. Head start. What does that mean? So let's say A and B. Finish to start. This time there's a lead of, let's say, 3 days. So whenever you put lead, you put minus sign, okay, because you're going back. So let's say A is taking 4 days. That's the duration for A. B takes 2 days. Or not 2 days, let's say 4 days. B also takes 4 days. Okay. So it's Monday, Tuesday, Wednesday, Thursday, Friday. So let's say A is starting on Monday. When it will end? Thursday. When do you think B will start? It will start 3 days earlier than Tuesday, right? Because there's a lead of 3 days. So that's a head start. So B will start here and it will end on Friday because it's taking 4 days. That's B. So relationship will look like this. It's finished to start only, but there's a lead of 3 days. Okay. So that's lead and lag. This is something that you input in the software. This is something that you want to induce. It's not something that you are getting. That's slack or float. That's different. Here you want this lead or lag. You know, usually in construction, you might have seen that once the concreting has been done, you need a little lag for the curing part before you start the next floor, right? Let's say 2 days, 3 days lag you need before you start the next floor. Okay. Mm-hmm. Yeah, it is FS, but we are saying that there's a lead of 3 days. That means we ourselves are inducing this, that we will start 3 days earlier than when it should have started. Sometimes this happens. I'm not saying that it will happen all the time. Sometimes you want this to happen. When do you want this to happen? Let's say your client is saying that we want the project early. Can you finish it early? Don't you think you would induce these leads? You would, although there B should start after A, but you would somehow start B, even A has finished, even before A has finished, so that things can happen quickly. Parallelly, you will do some work. Obviously, this increases the chances of risk. There will be risk induced, but sometimes you can't do anything. You have to do this, and you might have seen this example as well. Sometimes people do two things parallelly, even though it should have been done one after the other. Like what's an example? Example would be, let's say, something like yeah, let's say you are designing the software. Don't you think sometimes if, let's say, there is an urgency, you will start developing as well parallelly? Although the relationship is that you can't start developing until designing is finished. But don't you think sometimes this may happen when there is urgency? You might add a lead there, like we will start developing the software earlier than when it should have actually started, right? So this is not something that you have to do, but sometimes you might find yourself in this situation where you will be using this lead and lag, right? Okay. And this is something you will see in software as well. I'll show you one software where you can find this in P6. Let's say. So let's say here, you know, I have one. Let's say I'm adding one. Yeah, and in this, I'm adding two activities. 1, 2. One more activity. This is A. This is B. A takes let's say 1 day. B takes is it day or not? Okay. A takes 1 day and B takes, let's say, 2 days. So now I'll just put some relationship. I'll go to predecessor, assign B a predecessor as A. And now I'll add some lag as well. Look at the predecessor here. Relationship is, can you see all the relationships? Finish to finish, finish to start, start to finish, start to start. So this is finish to start. There's lag. I'm putting a lag of, let's say, 2 days. Let me not put lag right now. I'll just put 0. And I'll just schedule it without putting lag. And let me just change this weekday one. Yeah, so now you can see this is how it looks like right now without any lag. This is starting on Monday, this is starting on Tuesday. But what if I add a lag of 2 days? Now if I schedule it, just look at this. Can you see? There's a lag of 2 days, Tuesday, Wednesday, it's not there. What if I, let's say I'll just increase the duration of A to, let's say, 3 days. And I'll keep B as 2 day only. And I'll not keep any lag. Let's say there is no lag, 0 days. In that case, it is, now I'll show lead, how to add lead. So this is how it is looking like right now. But when I add a lead of, let's say, 1 day, 1 day lead means -1, -1. Now, in the lag only, you have to put -1. Can you see this? It's overlapping. So B is now starting 1 day before it should have actually started. So when you are in certain situation where you have to do something like this, then you can do it. You know, you have to add some lead. And I'll show you this example here as well. It's actually called schedule compression. You will find it somewhere. Yeah. What do you think? Is this what we are doing? Has anyone heard of fast tracking? We usually do fast tracking in that case. This is normal activities. 5 days, 5 days, 5 days. But what if there is an urgency? Your client needs the project early. What are you going to do? Would you not do this? Will it not increase your risk? One way is you will do this. You will add lead to all the activities. Like you will start the next activity a little earlier than when it should have actually started, even before the previous activity has finished, because you don't have any choice. Yeah, there's a risk. You are accepting that risk and you're going on. Other way is crashing. That means you will add more resources. When you are adding more resources, it will increase your cost. But when you're overlapping them, it will increase your risk. Is that clear to all of you? Yeah. The application of lead and lag. Okay. And now going back to that network diagram, where is that? Yeah. Here also you can see these leads and lags they've added here. And I think in the book of tools and techniques also you might find this. Have they added anywhere? Yeah, there it is, leads and lags. So you can see some examples here as well. So you are gathering requirements, but you know, you have started designing as well parallelly because there is an urgency. So 2 weeks before I'm done gathering the requirements, I will start designing the center. Okay. And sometimes it might be a genuine relationship as well. So I will finish editing the user instructors 5 days after I finish writing. So that's lead and lag. And this way you can use it in your network diagram as well. Okay. So they have given very nice examples. So I would suggest you all to check this out, this particular, you know, a book, this book of tools and techniques. You will get lots of examples there. Okay. So let's move on to the next. Yeah. Let's move on to the next thing. Yeah, I told you that I'm going to show you one example of this. You know, relationship. I'll give you one break as well. Let's just finish a few more things. Then I will give you one break. So where is that? This one. So let's say this is your project. Okay. What do we know right now? We know two things. What are these? One thing that we know is activity list, and what's the other thing? Predecessor. That's it. Just these two things we know, nothing else, right? So how can we develop a network diagram? So which is the very first activity in the network? Because our goal for this process is to develop a project schedule network diagram. So we have the activity list from the previous process, which was define activities. This process is about sequencing, so we got to know about the predecessors as well. And you can see we have assumed a finish to start relationship in this one, so that's fine. Now tell me, which is the very first activity in the network and why? Which is the very first activity and why? Why A is the first activity? Right, that's correct. So that is the reason why A is the very first activity, because it doesn't have any predecessor, right? That means it's not dependent on anything. You can start A first. So before drawing the actual network diagram, I'm just giving you a trick. Before drawing the actual network diagram, first draw small links. So first is A. What is next? B's predecessor is A. So can we put it like this? A to B. Then C's predecessor is A to C. Then D's predecessor is B. So B to D. E's predecessor is C to E. Then F's predecessor is D. So D to F. F's predecessor is E to F. G's predecessor is F, so F to G. Now, just create the network now, one by one. Which is the first activity? A. Let's put it here. A is done. What's next after A? You can see that A is common to both of these successors. So will the network diverge or converge? What is going to happen now? A is the common predecessor to two activities, B and C. Diverge. So it will diverge. And why it is happening like this? Because the relationship is finished to start. You can see it's starting from right side of A, ending on left side of the successors. So it will diverge into B and C. This is done. This is done. After B, next is D. B to D. After C, next is C to E. After D and E, there is a common successor. What will happen now? There is a common successor after D and E. This is a successor. So will the network converge? Right. So it is going to converge now. So this is done. This is done. After F, we have G. This is G. This is how you create a network. You can see how easy this is. I already have a screenshot of this. I'll share it with you, but I think it's very straightforward. So we don't have the duration yet. You can see we don't have the duration, so we cannot develop the schedule right now. We can just develop the network diagram. So we need to go to that process next, which will help us to develop to identify the duration. So once we get the duration, then only we will be able to develop the schedule. Right now, we just know the network diagram. So this is network diagram. And what is this project schedule network diagram? This is the output of this process. It says project schedule network diagram is a graphical representation of logical relationships, also referred to as dependencies among the project schedule activities. It's produced manually or by using project management software. So using some software also you can develop this. Next is the last process before we develop schedule, which is activity duration, estimating activity duration. This is something that we already know. Why? Do you remember the tools and techniques? I told you the same tools and techniques will be used for estimating duration, expert judgment, analogous, parametric, 3-point, bottom up, right? Same tools and techniques that we saw earlier. So they have not even repeated this in the PowerPoint as well. If you go to the PowerPoint, they have just mentioned 2 slides. That's it. They have not repeated these tools and techniques again. So estimate activity duration is the process of estimating the number of, and one more thing, the network diagram that I showed you just now, I have a screenshot of that, this one. So I'll share it with you. This thing. It's fine. Okay. So estimate activity duration is the process of estimating the number. Let's finish this process. It will just take 5 minutes, and then we'll take a break. And after that, we'll develop the schedule when we come back. So estimate activity durations is the process of estimating the number of work periods needed to complete individual activities with estimated resources, right? So this is where we need to identify the duration. See, we got the activity list from define activities. We got the sequence, we got the relationships. That means we know the predecessors. And the third thing that we need to know is duration. Once we know the duration, we will be in a position to develop the schedule. The benefit is that it provides the amount of time each activity will take to complete. So how do we estimate the duration? We need to know a few things. So this is what we get, duration estimates. What are the techniques we use? These techniques. We already know these techniques. We have discussed them. So to estimate duration, at least you need the activity list, right? If you don't know your activities, how are you going to estimate the duration, right? So activity list is needed. Apart from that, what is the other requirement? Don't you think this resource requirements? If you don't know the resources, how are you going to estimate the duration? Not possible. If you have more resources, you need less duration. If you have less resources, you need more duration, right? That is something which is needed. 1 second. That is something that you need. Yeah. So one is activity list and other is resource requirements. Apart from that, obviously other things will also be useful, like resource calendar, just to check when resources are available, when they are not available and stuff, right? But yeah, these are few important inputs you see here logically. Now the next thing is we use these tools and techniques, we get the duration estimates, and along with that, basis of estimates as well, where you will provide information about how you came up to these estimates, what was the basis of estimates, and all, your assumptions and all. But in the PowerPoint, they have not mentioned about basis of estimates. So you get you send these two into project documents that you see on page 126, and this is your activity. Your duration estimates. Where is that? Duration estimates. These are quantitative assessments of the likely number of time periods that are required to complete an activity, phase, or a project. And they've mentioned this here as well. Quantitative assessments of the likely number of time periods that are required to complete an activity. And what is elapsed time? Elapsed time is simply a calendar time. It's the actual calendar time required for an activity from start to finish. Let's say I'm saying that this work will take 1 week. So I mean, yeah, I'm saying 1 week. I'm saying the elapsed time, but I actually mean 5 days duration, because in that 1 week, only 5 days will be the working days, right? So that's duration, but elapsed time is the calendar time. When we talk about it, we talk in terms of 1 month, 2 months, 1 week, 2 weeks, like that. Effort, the number of labor units required to complete a schedule. Do you know in traditional projects how effort is measured? In Agile, it is measured in story points. In traditional projects, it's measured in terms of what? In Agile, we measure the effort in terms of story points. In traditional projects, we measure in terms of what? Time, don't you think? Labor hours, labor days, staff hours, staff days, man hours, man days. That's what we use, right? I hope you all remember. We discussed this already in Agile as well, right? I gave you the example of painting and all, right? So that's what effort is. Number of labor units required to complete a schedule activity or WBS component, often expressed in hours, days, or weeks. So when we also go to work, how much effort do we put into the work? How is it measured? It is measured in terms of time. 8 hours a day. That's the effort that you put into your work. 1 day work. So that's what effort is. And these are some guidelines. They have not even mentioned or explained these tools and techniques, you can see, because these have been explained already earlier, earlier, these tools and techniques have been explained in estimating cost. So involve the work package owners or others who are familiar with the work, consult lessons learned and historical information. So lessons learned is also there, you can see. Then you have review schedule management plan. Obviously, that's where you'll get the guidelines and rules. Determine how you want to quantify the work. Consider resource requirements. Resource requirements is there. Review the resource requirements for each activity. Check the resource calendars to know when resources are available. Consider interactions with other projects or operations, right? Then you have review the project scope statement. Project scope statement you get inside scope baseline. Then review the risk register we have for the reserves and everything. Review the resource breakdown structure. This is the resource breakdown structure because you need to assign these resources to your activities. Use tools and techniques. So they have not mentioned which tools and techniques, but yeah, these are the tools and techniques we already know. That's the whole point of using PMBOK. If you know how to use PMBOK, process domain will be very easy. Document means output. This is output. What is the output? Activity duration estimates. So duration estimates is the output. So the last process that we are left with is develop schedule. This is where we are going to develop schedule. And what method are we going to use? Critical path method. That's what we are going to discuss next. So it will take another 1 hour, you can say, for discussing this developing schedule part, and another half an hour for discussing earned value management. So another 1.5 hours of session is left. So let's come back after a 15 minutes break. And after that, we are going to develop the schedule and we will discuss earned value management as well. So do come back after 15 minutes. I'll pause the recording. Okay. So the next thing is we are going to discuss about this schedule presentation format. So project schedule could be any representation of your schedule, like it could be a Gantt chart, it could be a network diagram, it could be a milestone chart, anything. So let's learn about this, how to create Gantt chart and project schedule network diagram. Okay, all right. So 5 participants are back. Okay, so let's talk about how to create Gantt charts, network diagrams with it. It's basically how to create a project schedule, right? So now we'll use Excel for that. We can do that on whiteboard as well, but Excel will be quick. So develop schedule is the process of analyzing activity sequence, duration, resource requirements, and schedule constraints to create a schedule model for project execution, monitoring, and control. So of course, it will help you not only in executing the project, but also in monitoring and controlling. The benefit is that it generates a schedule model with planned dates for completing project activities. So this is the process, develop schedule, and you can see what we do here. We we need 3 things at least to develop a schedule. One is activity list. What is the other thing? Duration estimates. What is the third thing? Relationship, network diagram. And what are we going to use? Critical path method. That's what we are going to learn. And what are we going to get? Schedule baseline. Along with that, project schedule, schedule data, project calendars, and all. But the main output here is the schedule baseline along with the project schedule, right? That's what we are going to get. Here also you see leads and lags and stuff, but that's not really something that is mentioned in the PowerPoint. So from here, we get the schedule baseline, which goes into the PMP. We get the project documents like project schedule, schedule data, project calendars, which goes into project documents here. So now let's see what is critical path method. So it's a huge method. I mean, it's huge explanation, but we'll make it simple. And let me take one example. So which example shall we take? We'll be working on this example. Take the screenshot of this example quickly, and then we will try to solve it. Can you see all the details are here? You have the activity list, you have the duration estimates, and you also have the sequence details. You have the predecessors. Okay, all the 3 information are there. So please take the screenshot of this so that we can solve this. This is the problem statement. Remember, I told you that these three things you need. First, activity list, then duration estimates, and the third thing was the relationship, predecessors, right? That was the third thing that we need. So we have all these, and now we are going to talk about the next. Okay, so let's talk about the so I hope you all have taken the screenshot. Yes or no? This is the question that we are going to solve. Just take a picture using your camera, mobile phone, or screenshot, because we'll be solving this. Okay. So we have the list of activity, duration estimates, and relationships, predecessors. Okay. So I hope you have taken the screenshot for this problem. So this is what we are going to solve now. Okay. So let's solve this. Let's create a schedule for this. So as I said, we'll be using an Excel sheet. That will be the easiest one. So we'll learn how to create Gantt chart, and also we'll be learning about critical path. Actually, Gantt chart was created by Henry Gantt in 1910. It's even older than Kanban boards, right? So yeah, when Henry Gantt created Gantt chart, it was not how it looks nowadays. It was simpler. It didn't have any relationship lines or anything, just the activity bars shown in the chart. So you will see that. So let's create a Gantt chart for this particular example. This example. Okay. So here I'll put activity, no, date. There are few templates also you can find on Excel related to Gantt chart. If you go to file, and if you go to more templates, here you can find Gantt project planner, agile Gantt chart, project timeline, roadmap also you can see, schedule. Lots of templates you can find here. Some of them might be useful for you. You can check them. But we'll create our own template, not a problem. We'll create it from scratch. Date, day, and I'm explaining you Gantt chart to make you understand few concepts related to scheduling, which you need to understand before we move on to critical path method. Project start. So let's assume a project start date to be upcoming Monday. Upcoming Monday is on 29th of August. Yeah. Let's say that's the start date of our project. So I'll start my Gantt chart on 29th August. And it's a Monday. Saturday is Sunday. I'll share with you this Gantt chart, so no need to worry about it. Okay. So now let's put these information, and we need to find out project finish date, project duration, critical path, and all. So I'll explain you what is critical path. But yeah, this is the template. Which is the very first activity? When will it start? You know that A is the first activity because it has no predecessor. When is A going to start? On which date? It's taking 2 days duration. So A will start on first day of the project, 29th August, as early as possible, right? So when will A finish? If it is starting on 29th, will it finish on 30th or 31st? Or 1st September or 2nd September? Look at the duration of A. You already have the screenshot of the question. So when will it finish? On which date? Will it finish on 31st? So if your training, let's say, is of 2 days and it's starting on 29th, will it finish 30th, right? So it should finish on 30th. So 30th of August, that's when it will finish. And I'll just mark this. This is A. Now, what's the next activity after A? Let's see. After A, we have B and C. B takes 5 days. When will B start? On which date B will start? The relationship is that relationship is finished to start. So B cannot start until A finishes. So when do you think B can start as early as possible? All of you. On this day, 31st of August, Wednesday, and that is B. So B takes how many days? 5 days. So it will finish on 3 days here, 2 days here. Saturday, Sunday is a holiday. Don't consider Saturday, Sunday. Wednesday, Thursday, Friday, then Monday, Tuesday. These are the 5 days for B. So that's B. Along with B, C will also start after A, and C takes 3 days. This is C. 3 days. This is C. So B and C, both of them are starting after A has finished. Okay. So B and C cannot start until A finishes. After that, D. D's predecessor is B. D takes 3 days. When D will start? D cannot start until B finishes. B finishes on 6th of September. So D will start on 7th of September, right? And it takes how many days? 3 days. So these 3 days. Merge this. Yeah, that's D. Now E cannot start until C finishes. So C finishes on 2nd of September. So E has to start on 5th because Saturday, Sunday is a holiday. This is E. E takes how many days? 2 days. Now F cannot start until D and E finishes. So D and E, when do you think F will start, all of you? F cannot start until D and E finishes. On 13th of September, okay, 12th of September. Okay, so one of you are saying 13, one of you are saying 12. And just read the relationship. It says F cannot start until D and E finishes. So D and E both are finishing on 9th of September. Both of them. I mean, E has already finished on 6th. D is taking time. So D is finishing on 9th. So by 9th, your predecessor has finished. That means as early as possible, you can start by 12th because that's the next working day. So this is where F is going to start. F takes 2 days, these 2 days. Yeah. So that's F. The last one, G. G cannot start until F finishes. So G will start on 14th. So it's that easy creating a Gantt chart. This is G. And I'll just mark the end date as well. I'll also add some arrows, just the arrows or links where it is required. I'm not putting the obvious ones, just the things where it might get confusing. And I don't need to put these arrows here. I mean, it's understood. It's also difficult to put arrows here. B and C are related to A, we know that. G is related to F, we know that. But for other ones, I have put the arrows. Okay, what's the project finish date now? What is the project finish date? 14th of September, right? What's the project duration? Count the working days only. 5 days here, 5 days here, 3 days here, 13 days, right? Now the critical path. We'll talk about critical path now. Does anyone know about critical activities? What is a critical activity? Has anyone used them in their project? What do you think they are? Critical activities. Anyone? The one which takes more time. Okay, so in this, no, that's not the correct definition. What do you think? The one that cannot be delayed without affecting the end date of the project. Yeah, that's correct. Because if you delay them, yeah, one which has more impact, but how? In what form? It would be in the form of delay, right? I mean, if you delay that, the whole project will also get delayed, right? As Sergio was saying that if you delay these activities, it will impact the project. It will delay the whole project as well. It's not true with all the activities. Like I'll give you one example. Throughout your day, there are some critical activities. Like if you delay those activities, everything else will get delayed. Let's say an example is sleep. When you sleep, your sleeping is a critical activity. Because let's say you have decided that I'm going to sleep for 8 hours fixed. But let's say you slept late at night, 2 o'clock. You slept at 2 o'clock at night. So obviously everything else will get delayed now because you delayed your sleeping time. Uh,
by 3 hours, let's say. So you are going to wake up at 10 o'clock as per your fixed duration that you have put for sleeping. So you'll wake up at 10 o'clock. Then everything else will get delayed accordingly. Your whole day will get delayed. Then again, you'll be sleeping late only at 2 o'clock. That's how the routine gets impacted if you delay any critical activity. So sleeping is a critical activity. Usually what we do is we just sleep less just to compensate for that delay, right? But actually, if you fix the sleeping time 8 hours, you will see that everything else is getting delayed. Why it doesn't end up delaying? Because we reduce the sleeping time, right? We make it 6 hours or 4 hours. But in projects, it's not possible to reduce the duration of activities. In real projects, it will take certain amount of time. Right? We usually, lunch, breakfast, dinner, all these are critical activities. Time you need to get ready for work, these are critical activities. If these start late, or yeah, if it starts late, you are going to delay the further activities. Let's say you will reach late at office and all that. So it's all connected, it's all linked together. So there are lots of activities in a day which are critical. Okay, and if you delay them, your whole day gets very, delayed. Uh, and it's since it's a cycle, so it just impacts your routine as well. So let me define critical activities for all of you here. And I'll define in a very generic sense, in a very easy way, so that everyone is able to understand. Okay. Critical activity. An activity which, when delayed, will end up delaying the project finish date. I hope this makes sense, right? An activity which, when delayed, will end up delaying the project finish date. Okay, that's a critical activity. Okay, now which activities here are critical? What do you think? Which activities, which is the very easy to identify critical activity, easiest of all, that this has to be critical, you're sure that this has to be critical? Anyone? Is there any activity you see here which you're saying that it has to be critical? It, yeah, A, B, D, F, G, these are critical, but if you have to identify the first one, okay, some of you are saying that B, Vishwanath says B. Yeah, I mean, if I go by the logic, if I go by this definition, an activity which when delayed will end up delaying the project finish date. I think in this definition, one very important point that is mentioned is the project finish date. So that means I need to look at the project finish date, which is this line. So something which is just at the edge of this line has to be critical, don't you think? So G has to be critical. Why? Because G is just at the edge of the line. Don't you think? If G gets delayed by even one day, it will push this red line and your whole project will get delayed. So can we say G is critical, right? G is surely critical. I'm just showing you a very logical way to identify critical activities, which can work most of the time. Okay, so now you need to find out an activity which is capable of delaying G by even one day of delay, because that will also delay the red line. Which activity is capable of delaying G by even one day of delay? F, right? It will be F. So F is surely a critical activity, because if you delay F by even one day, it will push G, which will push the red line. Now you need to ask yourself, which activity is capable of delaying F by even one day of delay? D, right? Because, but for F, the predecessors are D and E. But E is having this gap. So E, if it gets delayed by 1 day, it cannot affect. So D has to be critical. Now you need to ask yourself which activity is capable of delaying D by even 1 day of delay. B. So B is the driving activity for D. And now which activity is capable of delaying B by even 1 day of delay? A. So this is the easiest way to identify critical path in a logical manner, just by going by just by going with the definition. So now let's identify the critical path as well. Mhm. Mhm. Yeah, because at the start you again have to see everything. Like when you're starting with A, you have to see, okay, how is A impacting everything? And then you will end up here. Then you will start with B, you will see. So you have to travel the whole chain if you start from A, right? So if you start from G, you don't have to do that because you're already at the end, right? So that's the advantage you have there. So I usually prefer this method, going backwards. So let me define critical paths. And this is just a logical way. I'll show you a more legitimate method of identifying critical activities. That's through critical path method. Right now, we are not discussing critical path method. We are just learning few concepts. So critical path means a path connecting critical activities in a network diagram. A path connecting the critical activities in a network diagram. That's critical path. So what is the path? What is the critical path here? A, B, D, F, G. That is the path connecting all the critical activities. So A, B, D, F, G. And let me show you one more way to identify critical path actually. It's called longest path method. You know the network diagram what we had? A, then we had B, C. After B, we had D, E. After D and E, we had F and G. And what's the duration of each of them? 2 days for A, 5, 3, 3. You can check the duration, it's same. Now, what are the two paths here? One path is A, B, D, F, G. That's one path. What is the other path? A, C, E, F, G, right? Two paths are there. A, B, D, F, G. And there is A, C, E, F, G. Now, which is the longest one? Just count the number of days for each path. First is ABDFG. 2 plus 5, 7 plus 3, 10 plus 2, 12 plus 1, 13. One path is 13 days long. Another path, A, 2 days plus 3, 5 days, so 7 plus 2, 9 plus 1, 10. So which path is longest? ABDFG. So can we say ABDFG is the critical path, right? A, B, D, F, G. This is the critical path. So that's another way to identify critical path. Usually critical path, that's one characteristic of a critical path, that it's the longest path in the network diagram. So here I'll just mention in this one. It is the longest path in the network diagram. That's critical path. Now, let's talk about the next thing. So we have discussed about critical activities and critical path. Now, let me ask you a few more things. Okay. Now let's say you are the project manager of this project and today is 31st of August. And there is some shortage of materials, shortage of some resources, which due to which you can just start one of these activities because there is a shortage of resources. So you can't really execute both the activities on this day. You just have limited resources on this day. So you have to make a decision. What would be your decision? You will start B and you will delay C, right? Because if you delay B and you start C, that means your whole project will get delayed. It will impact your whole project, right? So as a project manager, you are a very important, you make very important decisions throughout the day. So if you have the knowledge of critical activities, it will help you in decision making as well. Otherwise, you'll make decision randomly, right? If you don't have this information. So project managers usually care about these critical activities. They want to know these critical activities. For today, what are my critical activities? And they make sure those critical activities happen. They get completed. So in general, also throughout a day, in your personal work as well, or any work, you have some critical activities that you should finish on that day. If you don't do it, your whole project will get delayed. Okay, so that's how it helps us in decision making. Okay. Now, my question is, can you keep on delaying C for as long as you want? Like, can we delay C for as much as we want, or is there any condition there? How long do you think we can delay it? For how long? Maximum 3 days? Yeah. So maximum you're saying 3 days we can delay. So that 3 days that you said that we can delay C for 3 days. And what will happen if we delay it more than 3 days, Sergio? Right, right. It will impact the end date of the project. And the 3 days that you said is actually the flexibility that you have for C in the schedule. And that is known as total float. Technically, we call it as total float. And if someone is using Microsoft Project, they might be using the term Slack. Slack is another term used for it. Total float or Slack. The total float, let me define total float. It's a very simple thing. You just have to understand the definition. Very clear. Total float. The maximum amount of time an activity can be delayed without delaying the project finish date. Is that what you mean by total float? What do you think, all of you, right? Maximum amount of time an activity can be delayed without delaying the project finish date. That's total float. Why do we call it total float? Because the impact of total float is on the total project. So what do you think? What's the total float for A? What's the maximum amount of time you can delay A without delaying the project finish date? 0 days, right? Because you cannot delay A without delaying the project. So can we generalize this for all the critical activities? Total float being 0, right? So for all the critical activities, total float is going to be 0 because you cannot delay any critical activity without delaying the project finish date. Okay, so one fact that we identified here is that for critical activities, total float is 0. Let me just mention it here. Total float, or it is 0 for critical activity. It is 0 for a critical activity. Okay, so this is total float. It's 0 for a critical activity. So for C, now what will be the total float for C now? C is not a critical activity. 5 days. So are you saying that we can delay C for 5 days? 2 days. So that means you can delay for 2 days. After 2 days, it will impact the project finish date. So 2 days means you can delay it till 6th of September. Is that right? It's ending right now on 2nd September. So you're saying that you can delay it till 6th of September. So after 6th of September, what will happen? What's the next activity? E. When E will finish 8th of September. So do you think still some float is left, or have you considered all the float there? F is starting on 12th. E is finishing this way on 8th. Yeah, so you would you not consider that in the float itself? Because you said 2 days. So don't you think in 2 days we still have 1 day of flexibility left? So what should be the total float for C? 3 days. Because if it is 3 days, that means C can be delayed till 7th of September. E can start on 8th. E can finish on 9th. Still, F is not getting affected. Okay. So total float for C is 3 days. What is the total float for E? Now forget about C. Just look at E. For how many days can we delay E without delaying the project finish date? 3 days, right? And those 3 days you can see here also. E is finishing on 6th. So you can delay E for 3 more days, 7th, 8th, and 9th. And that's 3 days. That's the total. Right. So whenever, and all these total floats are connected to each other, don't you think? If you consume 1 day of total float for C, don't you think E will also be left with 2 days only? Let's say if you use 1 day of float in C, how much float will be left for E then? E and C, 2 days only, right? So these are connected. It's not like E has 3 days and it will remain 3 days even if you just delay C. A delay in C will impact the total float of E as well. That's why it's called total float, because that's for the total project. Now that was total float. Next thing is, what do you think? Delaying C, will it affect E? If let's say you want to delay C, would you need permission of E? Would you need to inform E at least before you delay C? Right, you need to do that because C, delay in C affects C. What if you want to delay E? Do you need to inform F? No, or never, is it? Or after some time you need to inform? Yeah, so how many days is that? 3 days. So the 3 days that you said is called free float. Free float. That is the float for the successor. That means the number of days you can delay an activity before it delays the successor. That is free float. The maximum amount of time an activity can be delayed without delaying not the project finish date this time, without delaying the early start of its successor. What do you think? This makes sense? The maximum amount of time an activity can be delayed without delaying the early start of its successor, right? So how a particular delay in your activity is delaying the successor. That's your free float. Let's say in this one, I'll just help you understand this. So what's the free float for A? What do you think? For how many days can you delay A without delaying its successor? Successor of A is B and C. 0. So can we generalize this for all the critical activities? Because none of the critical activities you can delay without delaying its successor. When you delay a critical activity, it will always delay its successor. It has to be 0. Now, what about C? What's the free float for C? 2 days. You're saying we can delay C for 2 days without delaying E? For how many days can you delay C without delaying the early start of E, which is the successor? 0, right? Because the early start of E is 5th of September. That's as early as possible it can start. So you can't actually delay C without delaying E starting at 5th of September, right? If you delay C by even 1 day, E gets pushed. Now, what is the free float of E? For how many days can you delay E without delaying the successor? 3 days. All of you agree 3 days, right? So 3 days will be the free float of. That's the number of. And easiest way to identify free float is find the gap between two consecutive activities. Do you see a gap between two consecutive activities here? Between E and F, right? E and F, these two are two consecutive activities, and there's a clear gap between them. That's a free float. Okay, so that's the easiest way to identify a free float. So I think with this, we have understood all the concepts that we should have known. And now we can discuss the critical path method. So let's quickly discuss the critical path method. Critical path method will take maximum half an hour. Then we'll switch to earned value management. That's the last thing. Okay. So critical path method. Now, let me ask you a question. Have we used any legitimate method here to identify critical activities, or it was just based on logic? Do you think this kind of method, it was logical, right? This cannot be used by software, this method, right? If you're using any software cannot use this method because you need to feed some formulas and stuff to a software. So we haven't used any formula or anything. So it's not a legitimate method. Now forget about the fact that you have already identified critical activities. Just think that you haven't identified critical activities now. You know what are critical activities by definition and everything. You know what is total float and all by definition, but you do not know what are critical activities in this example. Just assume, okay, because we are going to find it again by using a legitimate method. Assume that you do not know what are the total floats of these activities. Okay, so let's see. Let's use critical path method, and here they have mentioned this critical path method. Either you can read this whole thing, otherwise, not needed. I'll just explain you in very simple terms. So the same problem, this one, we are going to solve using critical path. So for that, what we are going to do is we have to create a network diagram just like this. So you might be wondering that the network diagram looks fine. A, B, C, D, it's fine. There are links and everything. But what about these boxes? You might be confused about these boxes. So boxes you can see here. This is a template. And if you're wondering what these boxes mean, see at the center you have activity name. That's name of the activity. That's very simple. Above that you have duration. Here you have to put the duration of activity. Here you have to put the total float. You need to put it or identify it. Early start, early finish, late start, late finish. These are the dates. What are these dates? Early start means earliest started date of this activity. That means when can you start this activity as early as possible? That's early start. What's early finish? As early as possible you can finish an activity. That's early finish. What's late start? As late as possible you can start an activity. That's late start. And what's late finish? As late as possible when you can finish that activity. That's the late finish. Okay? These are the 4 dates. So let me create this kind of a template now. Let me create this kind of a template. and let's see how it works. So I'll create this template now. We can do this on whiteboard as well, but Excel will be quicker. So I'll share with you this template and everything, this whole Excel sheet. So if you want, you can do, otherwise just see. At the center, there will be activity name. And here we have, what do we have here? Early start. Right here we have early finish. And you can check this here in this, then late start, late finish. LS, late start. LF, late finish. Here you have duration, D, and here total flow. Total flow, here. So I'm color coding this so that it's easier to understand, easier to recognize them. Okay, so this is a box, and box I have created. Now we need to create this network diagram. What shall we do? Shall I create this box again and again, or shall I just copy it at the location? Don't you think I should just copy it, right? Copy paste, 3, 4, 5, 6. One here, one here. I hope you're getting what I'm doing here. I'm creating that network diagram that we had created earlier. Remember that network diagram? Project schedule network diagram that we created. This is A, this is B, this was C. You have already drawn it, maybe. Is it? You can check. This is G, right? So it's the same network diagram. I'll add some arrows here. Shapes, arrows. And you will see what we are going to do with this. Okay. So what else do we know from the problem statement? Look at the problem statement. We knew the activity names, so we have put the activity names. A, B, C, D, E, F, G. What else did we use? Have we used the predecessors? Have we used this information, predecessors, already in this? Don't you think the whole network diagram is created based on predecessors only? Right? So predecessor details we have already used. Is there any other information that we know from the problem statement but we haven't put here? Duration. right? Because duration, you can see you have duration here, but we haven't kept it here. So duration is, see, duration, activity name, and predecessors. These are the only three things that we know, right? So duration, what are the durations? 2 days, then 5 days, then 3 days, 3 days, 2, 2, 1. These are the durations. Now, we have used everything that we had in the problem statement. We don't have anything left. We have used all the information that we know, that we knew earlier. What's our goal here? What do you think? We are using critical path method. What do we need to find out? The method is called critical path method. We need to find out the critical activities, right? The critical activities, maybe with dates and everything. So what should be our strategy? Which of these boxes we need to identify so that we know this activity is critical or this is not critical? One of these boxes, if I show you these boxes, there is one box here which can directly tell you, if you find its value, it can directly tell you whether the activity is critical or not critical. Which box is that? Total float, all of you agree? How many of you agree that total float is the box that if you find its value, you would know whether the activity is critical or not? Agree or not? What do you think? What should be the value of total float for the activity to be critical? If you want the 0, right? I hope all of you would agree that total float, see what you need, what our strategy would be to identify total float value. If the value of total float comes out to be 0, it's a critical activity. If it doesn't come out to be 0, it's a non-critical activity. This is something that we have already understood here. You can see the definition of total float here and see it is 0 for a critical activity. So that's a fact that we need to remember as a fact, that for critical activities, the total float will be 0, right? So that you need to remember. And that's what we need to find out. Total float 0 is. So if we can identify the value of total float, we would know whether the activity is critical or not, and that's what we want. But the next question is how to find out total float. So to find total float, we'll take the help of these dates: early start, early finish, late start, late finish. And now you might be wondering, what's the relationship between total float and these dates? So I would tell you that you're going to figure that out and you'll tell me the formula. And it's very easy actually. So let me give you one situation. Let's say as early as possible. Let's say you have to go for grocery shop. As early as possible, you can start by 7 p.m. As late as possible, you can start the grocery shopping by 10 p.m. What is the float? How much float do you have? As early as possible, you can start the grocery shopping by 7 p.m. As late as possible, you can start by 10 p.m. What's the float? Three hours. All of you agree? 3 hours? What do you think? Float means how much delay you can make. So how much delay you can make here? 3 hours. All of you agree, right? And how did we find 3 hours? What's the formula we have used here? LS minus ES, right? So that's the formula for total. Remember, let's start minus start. So it's, I didn't give you the formula directly. I just helped you figure it out, right? So late start minus early start. That's the formula for total float. There's another formula for total float. Let's say we need to finish this training as early as possible by 5 p.m. and we need to finish this training as late as possible by 6 p.m. How much float do we have? In that case, float will be 6 p.m. minus 5 p.m. 1 hour, right? So what's the formula? Late finish minus early finish. So both the formulas work for total float. Late finish minus early finish or late start minus early. Both of them could be used. Let me note down both the formulas before we start forgetting. So I'll just mention it here. Total float equals to late start minus early start, also equal to late finish minus early finish. So I've noted the formula so that we don't forget it. So we would be able to find out total float. And once we know total float, what are we going to figure out? Once we have identified total float, we'll be able to figure out whether the activity is critical or not critical. And we can find the critical path as well. So that's our roadmap to solve this problem. But what's the next question? Next thing is, what do we need to find next in order to get the total float? These dates, don't you think? Early start, early finish, late start, late finish. I mean, we need to find out these dates. If we don't get these dates, we can't get the total float. That is the thing. So how to get the dates? That is the next question. So to get the dates, we will be using two methods. One is forward pass method, through which we will get the early dates, and the next will be backward pass method, through which we'll get the late dates. Okay, so we'll be using these two methods. Let's first use forward pass method. Let's use the forward pass method and let's see how we can get the early dates. Uh, for forward pass method, we will go forward in time. So we'll start with the first activity, we'll go to the last activity. And forward pass method. Okay. All right, that's forward pass method, and using this we'll find the early dates. So I have color coded that in green. Why I've color coded that in green? Because using that we will be able to find out which dates, early dates. Can you see early dates are color coded in green, right? And that's why I've mentioned forward pass method in green. Okay, now we need to use forward pass method to find these early dates. So we'll be moving forward. Forward means from the first activity till the last activity. So what do you think? What dates shall we use? We can use calendar dates like today's, starting with 29th of August, then 30th August and all that. Do you think calendar dates is a good thing to use for calculations, or will it be confusing? Because there will be holidays and stuff. So you might get confused while calculating. What is a better approach? Shall we use ordinal dates like day 1, day 2, day 3, day 4, day 5, which can be converted to calendar dates anytime based on whatever day 1 you consider? So what do you think? What shall we use? Calendar dates or day 1, day 2, day 3, day 4? Which will be easier? Right. Day 1, day 2 will be easier. So let's start with forward pass method. So forward pass method means moving forward from the first activity to the last activity. So this is a first activity. What is the earliest start date of A? When can A start as early as possible? On which day? Day 1. That's correct. And A takes 2 days. When will A finish? Day 2, right? And that's very simple. Let's say this week, or I think on the 13th we had the training, right? So That was the second week. So let's say you started the training on 13, and that was the early start of the training, and the duration of the training was 2 days. So when will the training finish? Training will finish on 14th. So 13 and 14, these are the 2 days of training. Okay, so duration is 2 days, end date is 14. What is the early start of B and C? When will B and C start as early as possible? Day 3. I hope all of you would agree. Early start for B will be 3, early start for C will be 3. Because A has finished on day 2, so obviously B and C will start on day 3. What's the early finish of B? 7, right? So you don't have to add these two, remember. Many people add these two, 3 plus 5, 8. No, that's not 8, that's 7. Again, the same reason. Your training started on 13th. And if you add 2 days to start date, what are you going to get? 15th. That's not the end date of the training. It ended on 14th. Right? 13 plus 2. I mean, if you're adding 2 days, you should count 13 as well, 13 and 14. So here you should count 3 as well. So count 5 days from 3. 3, 4, 5, 6, 7. So that's day 7. What's the early finish of C? 3, 4, 5. Yeah. Now what's the early start of D? The next day? 8. And this will be 6. This will be 8, 9, 10. And this will be 6, 7. What will be the early start of F? When will F start as early as possible? As early as possible, you are saying it will start on 8. All of you agree? 8. Which means that you are starting F on day 8 and you are finishing D on day 10. So F cannot start until D finishes. But here F has already started on day 8. D has not finished yet. Is that correct or incorrect? It should be day 11, right? It cannot be 8. It should be 11. Why you said 8, others, like those who said 8? You have to look at this also. See, the driving activity is D, right? So as early as possible, F can start on day 11, not day 8. Because D will be finishing on day 10. So you have to wait for D to finish. Same decision you took here also. Remember, F you started on 12th September, not 7th September, right? Not just after. You waited for D to finish. That's when you started, right? So same logic you have to use here. So F will start on day 11. When will F finish? Early finish of F will be 12. It's taking 2 days. What's the early start of G? 13. Early finish? 13 itself. So can you see the duration? The project duration is also coming here, 13 days. Are we clear on forward pass method? What do you think? Are we clear on this, all of you? Forward pass method, these early dates, have you understood? Just give me a confirmation. If there is any doubt, you can ask me. I hope this is clear to everyone. How we have found the early dates. Okay, yeah. So now you might be wondering that can we have some formula for this, for finding the early finish from early start? Yeah, one thing I didn't do is I'll keep one template for you for later on. Like if you want to refer to this template, you can refer to this. With all the notations, early start, early finish, duration, and all. Yeah, now this is fine. Okay. So what's the formula that we can use? Let me give you a formula. You will derive the formula actually. I'll help you derive it. Okay. So let's say we know the early start. Okay. So let's say early start of the training in the official training that we had was 13th August. I need to find out the end date of the training. It was a 2-day session for this week. So I want to find out the early finish of the training. What's the early finish? Duration was how much? 2 days. So if I add duration to the early start, am I going to get the early finish? If I add the duration of the training was 2 days. 13 plus 2, you will get 15. But 15 is not the finish date. What are we going to do here? Minus 1. All of you agree or not with this formula? Early start plus duration minus 1 will give you the finish. What do you say? Early start was 13. If you add the duration of the training, which was 2 days, you get 15. Minus 1 gives you 14. Would you agree this formula will work? Or yeah, so number of days is this D. D is the number of days. Duration. Yeah, that's the date. So 13, like day 1, day 2, day 3, like that. Right? So 13, yeah, it's like day 13, let's say. You can take date as well. It's fine. I mean, 13, right? So 13 plus duration is 2 days. So 15 minus 1, 14. So you're back to 14 only, right? And you can check this formula here as well. Just check this. 1 plus 2 minus 1, 2. 3 plus 5 minus 1, 7. I want all of you to check this formula. 3 plus 3 minus 1, 5. 8 plus 3 minus 1, 10. 6 plus 2 minus 1, 7. 11 plus 2 minus 1, 12. 13 plus 1 minus 1, 13. Is it consistent? The formula? Is it working? Yeah. So this is forward pass method. So we got all the early dates. Now, how will we get the late dates? What are we going to do? Are we going to go back now? Right? We should go back in order to find the backward pass. So let's go back. In order to find the late dates, we'll go backwards. So you can see I'm using the color code yellow now. Okay, because it's backward passing, because we'll get the late dates. Okay, so from which activity shall we start if we are going backwards? G. So what will be the late finish of G? What do you think, all of you? When can G finish as late as possible without impacting the project finish date? When would you want G to finish as late as possible? 13 itself, right? It should be 13 itself, correct. Because if it is 14 or 15, then I think you are delaying the project in that case, right? So 13 is the late finish date. What's the late start date of G? Just go back 1 day from 13. So 13 itself, don't you think? 13 itself. You need to start G as late as possible on 13 itself so that you can finish it on 30 because it's taking just 1 day. When should F finish as late as possible so that G can start on 30? 12, right? Go back 2 days from 12, 12, 11. So 11 will be the late start. When should D and E finish as late as possible so that F can start on 11? 10 for both of them, D and E. Okay. For E, what will be the late finish for E? When should E finish as late as possible so that F can start on 11? 10. So 10 is correct for this also, 10. Right? So for E also it's 10 only. E should finish by 10 as late as possible so that F can start on 11. Go back 3 days from 10, 10, 9, 8. And here go back 2 days from 10, it will be 9. Right? Go back 1 day, that's the late finish, 7. This is 8. What about late start of C? Go back 3 days from 8. 8, 7, 6, right? And go back 5 days from 7, you will get 3. 7, 6, 5, 4, 3. What's the late finish of A? When should A finish as late as possible? So that B can start on 3 and C can start on 6. 2. I hope all of you would agree it should be 2, right? Because A has to finish by 2 so that B can start on 3. 6 is starting late, it's fine. But for B to start at 3, because B is the driving one here in this relationship. Now, late start of A will be 1. Go back 2 days from this. So let's figure out the formula. Okay, so let's say your end date of the training is 14th of August. So we know the late finish of the training. Now do one thing, subtract 2 days from 14, expecting that you will get the start date minus duration. Are you getting the start date of this training? Or do you need to do something? 14 minus 2 is giving you 12. 14 minus 2 is 12. We need to do plus 1. That's correct. So plus 1. That's it. So late finish minus duration plus 1, late start. This is the formula for backward pass. And I think even if you don't remember the formula, it's fine. You can derive the formula by the same logic, or you can logically only you can calculate these values just by counting. It's fine. 13 minus 1 plus 1, 13. 12 minus 2 plus 1, 11. 10 minus 3 plus 1, 8. 10 minus 2 plus 1, 9. 8 minus 3 plus 1, 6. 7 minus 5 plus 1, 3. 2 minus 2 plus 1, 1. Okay, so that's backward pass method. Are we in a position to find total float now? What do you think? Yeah, so what do we do? We should subtract late start and early start, or late finish and early finish. Both of them will give us the same value. So subtract yellow and green. 1 minus 1 or 2 minus 2, 0 days. This is 0 days again. 0 days. This is 3 days. 3 days. 0 days. 0 days. Okay. Right. So we got the total float. And which activities are critical? A, B, D, F, G. And I'll just mark that in red. And these are non-critical, C and E. Usually in software, they will represent it in green. And this is critical path. I'll convert that into red as well. Okay, so we didn't just find the critical activities and critical path. We also found the start and finish date of activities. Are you getting this? That this method is not just useful in identifying the critical path or critical activities, because we could have just used the longest path method for that. You're also getting to know the start and finish date of your activity. Would you not consider this as a schedule? Don't you think? This is your schedule. If you just add the calendar dates, it will become a schedule. Just consider day 1 as anything, 29th August or anything. Accordingly, you can find out the other dates. So softwares like Primavera, P6, Microsoft Project are using the same logic to identify critical activities and dates according to the critical activities. So that's the end. This is our project schedule. One representation is Gantt chart that we have learned, and also this is critical path method. So what do you think? Is this clear? Critical path method and Gantt charts. Are you clear with the concept of critical activities? critical path method and all. Let me know if this is fine. I'll just save this. I'll share it with you at the end. So, yeah, so I hope this makes sense to all of you. The critical path method. Okay. And let me show you the PowerPoint now. Now we'll start with earned value management. Quickly, we'll finish that as well. Let me just go through these few slides. They've mentioned the same thing that we have discussed. Gantt charts, a bar chart of schedule information where activities are listed on vertical axis, dates are shown on horizontal axis, and activity duration are shown on as horizontal bars, placed according to start and finish dates. This is how a Gantt chart looks like. I'll show you Gantt chart in the P6 as well, but we created Gantt chart as well. So you can see you can have activity names, duration, start and finish dates along with that. Milestone charts are more like at summary level, it shows the project milestones, but these are more useful for upper management, you can see, who are not interested to see fine details. This is network diagram with dates. And remember, in the PowerPoint, they have used a different convention. Can you see they are starting from 0, which doesn't really make sense. Here in the PMBOK, you can see they have mentioned. This example uses the accepted convention of projects starting on day 1 for calculating start and finish date. There are other accepted conventions that may be used. So here you can see they have started from day 1. But in the PowerPoint, in the latest PowerPoint that they have created, there they have used 0. Now that's a different convention. It's not correct or incorrect. We are not saying that it's right or wrong. It's just that it's a different convention. So you can use this one as well if you feel that this is more logical to you. I don't find this logical because day 0 doesn't exist. There is nothing like day 0. If you look at your calendar, there is no 0 August or 0 September. Everything starts from 1 only when it comes to dates. So I think 0 is a little confusing. It's really hard to understand what it means. So that's why I don't use 0. I use the same convention followed in PMBOK. But in many books you will find 0 as well. So if you have if this convention is fine with you, don't go with 0. It's again, it could be very confusing. So I don't know why PMI has done this. Maybe the whoever created this PowerPoint for them, they didn't consider the convention which is mentioned in PMBOK, but that's absolutely fine. It's just a different convention, and it's up to you which one you want to use. I would prefer the one that we have discussed just now. That would be better. Right? Yeah, that's the ID, activity ID. Yeah, that's the activity ID. Duration is here. We can see duration. And this is total float, right? So they have just used a different time. So don't look into this. It's confusing, right? Easier, better is just focus on whatever we have done. But here, these are more like IDs and stuff. Okay. They have not even used this template. It's a little different template there. Okay, so critical path, you can see the longest path is the critical path. That is something that you should remember. Critical activities, float, total float, free float. Agile release plan, I already showed you this, that in Agile we have number of releases. Every release has a number of sprints. Every sprint has a number of user stories in the sprint backlog. And each user story can be broken down into tasks as well. So ongoing progress based on methodology. So even after creating this schedule, you need to keep on measuring the project's progress. So monitoring the status of project to update project schedule, it's a regular task, and managing changes to schedule baseline. You might need to keep on managing changes to the baseline. While in agile approach, how do we monitor? We compare total amount of work delivered and accepted to the estimate of work completed. We review the completed work in sprint demos or sprint reviews that we conduct. Schedule reviews to record lessons learned or retrospectives, which are the sprint retrospectives. That's how we do the monitoring. Determine the rate at which deliverables are produced, validated, and accepted. So that is something that is run in agile projects. You might need to coordinate with other products as well. Sometimes what happens is when you are working inside a program, when your project is part of a program, a delay in your project might impact the next project as well, which is dependent on your project. Let's say project B is dependent on project A. So if project A gets delayed, project B will also get delayed, right? So that's why critical activities becomes more critical sometimes, because the if you delay these activities, it will not only delay your project, it might delay the next project also, which is dependent on your project. So the impact of a delay in critical activity could be huge, right? So they have given one activity here. They've given number of activities. They've given you the relationship, and you just need to find out this network. You can see it's easier than what we have already done. It's actually doesn't consist of forward or backward pass. It just has logical relationships. That's it. So you can see it's this network we already created back then, I think in schedule, in sequencing only. So this was schedule management. Here, the bad thing I find in this PowerPoint is they have not really defined the schedule baseline, although they should have. But it's fine. I'll show you the schedule baseline definition separately in the PMBOK. It's mentioned. It's there in the PMBOK. There it is, schedule baseline. So again, I will underline that common statement. Remember that common statement in every baseline definition. Baseline is the approved version of, because this is something you don't need to remember. That can be changed only. Did you remember this statement? This is the common statement that you find in every baseline definition. Baseline is the approved version of, that can be changed only through formal change control procedure and is used as a basis of comparison to actual results. So what is new here related to this baseline? A schedule. And what is a schedule baseline? What are you going to remember here? Would you remember the whole thing? Would you remember, or just this? That schedule baseline simply means a schedule model, whether that's a Gantt chart or network diagram, whatever that is, that could be considered as a schedule model. Do you remember the other baselines as well? What about cost baseline? Cost baseline, what shall we write here? Time phased project budget, remember? Time phased project budget. Was there anything else apart from that? There was one more statement, except what? Management reserve. Remember, you need to remember these statements. What was the last? There was one more baseline, scope baseline. What did it consist of? Project scope statement. A scope baseline is the approved version of project scope statement. What else? WBS and its associated WBS dictionary. Does all of you remember this or know about these three statements? What do you think? Are we fine with this? These three statements, would you be able to remember them? Because it's very necessary to remember these statements. I hope these three baselines are clear to all of you. The easiest to remember, I think, is the schedule baseline. And cost baseline also, I told you many times that it's time phase project budget, except for management reserve. And scope baseline, scope statement, WBS and WBS dictionary. So I hope that makes sense to all of you. Now, the last thing that we are going to discuss today is earned value management. So where is that earned value management? For rest of the topics, I'll share with you some resources. Most of the other topics are purely theoretical, nothing else there. And most of them we have already discussed in our discussion on Agile and few PMBOK discussions. So where is the earned value management? I think 546 or something. That was the slide number, right? One second. Yeah, this one, earned value management. So using earned value management, you get to know how your project is performing, whether your project is going on budget, under budget, over budget, on schedule, ahead of schedule, behind the schedule. So a methodology that combines scope, schedule, and resource measurements to assess project performance and progress. So let me take an example. So it's very easy. If you just focus, it will be very easy. Okay, just another 20 minutes I need to finish this earned value management. And actually, earned value management is a subject in itself, but for the exam, you just need few things to be understood. So there will be a question on earned value management, that is for sure. That's why I'm discussing this. So let's consider a project. Project name is, let's say, paint a house. And inside that project, there is an activity, just one activity for simplicity, paint the walls. Duration of this activity is 8 days. For this activity, you need resource. So we are planning this activity. So you need resource. You decided that I'm going to hire painter for this, and I'm going to pay the painter a total of $1,000 a day, including materials, helpers, whatever they need. It's fine, but I'm going to pay the painter 1,000. That's your plan. Whatever you're doing here is plan. What do you think is this budget at completion? We talked about budget at completion when we were discussing cost management, BAC. What is the budget at completion for this project? Budget at completion, $8,000. Yeah, $8,000. Can you imagine the cost baseline for this? How will the cost baseline look like for this project? Will it be like an S curve, or will it be a straight line, a linear line, linear graph? Straight line? Yeah. Yeah, that's correct. So it has to be linear, because every day we are planning to spend the same amount. So 8 days, 8,000, first day 1,000, second day 2,000, like that, right? So that's our plan. So this is our plan. Let me create a line. Let's say a baseline or something. Okay, this is my baseline. Above this, whatever is mentioned, that's part of the plan. How things are going to happen, actually, that I have no idea. Let's see how it happens. So let's say the project has started. 2 days have gone by. So you are taking the update of the project after 2 days. Everything is happening here after 2 days, whatever calculations we will do. So after 2 days, you are looking at project status. So you got to know that the resource that you had to hire, which is painter, you actually hired a painter. His name was Mr. John, let's say. You hired Mr. John, and when John was hired, like when you planned for this activity, you planned that I'm going to pay the painter $1,000 a day. But when you hired Mr. John, Mr. John said, no, I'm not ready with uh, with $1,000 a day. John said that I'm going to charge 1,200 a day. So that didn't go as per your plan. So John asked for 1,200 per day. What do you think is happening here? Are you under budget, over budget, late, early? What's happening at this point? Over budget. How many of you agree? Over budget? I hope all of you agree. What do you think? Yeah, everyone agrees that it's over budget. And I'm going to draw a graph as well here. Just let's do one one activity earned value EVM graph. Yeah, let's make it interesting a little. I mean, we can do this without graph as well. We can discuss this. So, yeah, they plan. Okay, so 1 second. Yeah, so tell me, what's your planned value? Planned value after 2 days. Planned value cost. Planned value cost means as per your plan, as per your baseline, how much money you should have spent in 2 days. In 2 days, $2,000. All of you agree? $2,000. That's our planned value cost because in 2 days we should have spent $2,000 as per our plan. What's our actual cost after 2 days? 2,400. I hope all of you would agree that it is 2,400. Which one do you think is time parameter? Which one is cost parameter? Like if I use the triple constraint triangle, in triple constraint triangle, we have time, cost, and scope. So plan value, is it a representation of time or is it representation of cost? Plan value. Can we say it's a representation of time because it's totally time dependent? Because on day one, plan value will be 1,000, day two, 2,000, day three, 3,000. So it's very linear with time. Can we say actual cost is linear with time or actual cost be anything on any day? It has nothing to do with time. You can't really predict actual cost. Can we say actual cost is the raw cost? So it's a cost parameter. How many of you agree that actual cost could be anything? On day one also, your actual cost could be $10,000. It could be $20,000. Some accident happened on site. There was a huge loss. So can we say actual cost is the raw cost? All of you agree? And plan value is a time dependent parameter. Are you fine with these two things that I've mentioned in the bracket? Time and cost? How many of you? Yeah, all of you agree, right? So that's plan value and actual cost. I hope all of you agree with these, right? Now, let me put that on graph. Day planned value. I'll just put PV. And this is AC. 1 second. With graph, we can make it interesting. No. 1. And then plan value. What's the plan value on day one? It's 1,000. I think throughout all these days, it's 1,000. Right. And what's the budget at completion? It's the sum of this. So can we say this is budget at completion? I can mention here BAC. Budget at completion, $8,000. Right. Or I'll just mention it here, BAC. Actual cost, 1,200. 1,200. Where are we right now? We are here. Yeah, this is where we are, end of day 2, after 2 days. Okay, so let's create a graph for this. Insert. Let me add a chart. This one. Can I get a cumulative combo chart? Select at least 2 series of data. Okay, let me select these 2. But I'm not getting the cumulative cost. 1 second. Okay, I've done one mistake, sorry. What's that mistake? Plan value will keep on increasing every day, right? Because it's just the cost here. Cost per day. Plan cost per day, right? This is different. 1 second. And actual cost per day. Plan value will get on accumulating every day. This is actually plan value cost per day. This is actual cost per day. Although this is something else. I'll show you. You'll get this, I mean, once I show you this. So plan value is not 1000 every day. I mean, by the end of day two, plan value is how much? 2000, right? It's not 1000, it's 2000. So it will get added up every day, right? So equal to 1000. Then next day equal to this 1000 plus what? This 1000. So it will keep on getting added every day. And where will it reach at the end of day 8? It will reach 8000. That's your BAC. Right? So that's how we should look at it. So this is our BAC, budget at completion. Okay. And what is our actual cost? Equal to this 1200, equal to 1200, the previous one, plus this new one, 2400. So this is your actual cost on day two. This is what we are looking at right now. You can see. Are you getting this? This is where we are right now. Here. I'll just highlight this. Right? This is where we are. So can you see plan value and actual cost? So all of you are saying that, okay, let me create a graph as well. Insert. I'll create this. One for value, one for this. Are you fine with this? What do you think? Is this what the cost baseline will look like? What do you say? Let me know if you agree. Are you getting this? This is our cost baseline or no? Cumulative costs. This is our cost baseline curve, straight line. 8 days, we can see 1000, each day 1000. I'll add this actual cost as well. Can we add a new item here? What is this one? Clustered column line for this is. Let me see if I can change its property a little. Land cost, I'll add one more. I'll add can you see the actual cost as well now? What do you say? Does that make sense to everyone? Can you see actual cost? Is that the reason you're saying that it's over budget on day 2 because of this value? What do you say? I'll just, for your convenience, I'll just do one thing. I'll add 10 as well here, so that the starting point, you know that it's 0, so that it starts from 0, you know, and for this line, yeah, I'll just keep 10 as well. Now it's starting from 0. No, that's not good. No, this is fine. I thought it will work. No, it's not working that way. It's fine. We'll just delete this. So is this how the chart will look like? What do you say? EVM is what we are learning. This gray line that you see, that's your actual cost, and this planned value you can see. So you're saying that it's over budget because on day 2, this line is above planned value, right? So that's the reason you're saying that it's over budget. But now, see, you all are missing one point here. What is that point? You're assuming that actual cost is 2400, so everything is spent in doing the work. That's what you're assuming. Do you know how much work is completed? How can you say that it's over budget? Like all of you said this is over budget, but I don't agree this is over budget. Why this is not over budget? Because this might not be over budget. This could be over budget as well. But what I feel is that you don't have enough data to say anything right now. You can't say whether it is over budget or under budget. What's the reason? What do you think? Anyone knows the reason why we can't say? No, and on day 2 also, when you're saying that it's running over budget right now, I don't think that you have the sufficient data. Yeah, that's correct. You don't know the work, how much work that Mr. John has done. Maybe Mr. John has completed 50% of the work. Then what? Then it's not over budget, right? So you cannot compare these two things. Remember, this is the mistake people make. They compare planned value and actual cost, which are not comparable at all. You cannot compare these two and say that my project is over budget or under budget. My project is over budget because my actual cost is more than planned value. That's incorrect, totally incorrect. You can't compare these two values. Now you might be asking, then what do we have? How can we find out whether our project is over budget or under budget? So for that, you need to know how much work is done. So I will give you one value which will turn everything now. Percentage work completed. That is 40%. Now tell me what's going on. Now you have all the data. How is it going now? Under budget, over budget, late or early? What do you think? Yeah, so is it under budget, over budget? Under budget and late or early? Early. So it's early and under budget. Others, would you agree? What do you think? What do you think is happening now? 40% of the work has been completed in 2 days only. Early and under budget or over budget? It's under budget. So it's clearly early and under budget. with respect to time also you're doing good, and with respect to cost also you're doing good. So you can see how things changed. So initially you assume that it's over budget, but you didn't really ask for this value, percentage work complete. This is really important to know, right? So you cannot compare time and cost. It's not comparable. These two are two different things. So what do you need in order to find out whether the project is under budget or over budget or late or early? You need the third element, which is earned value. EV, earned value cost. So now tell me, what is the value of work that is completed till now? What is the value of work that has been completed in 2 days? Total value of work was $8,000. What is the value of work that has been completed till now in 2 days? Yeah, so how much is that? 32. Yeah, 3,200. That's the value, monetary value of work that has been completed. Because monetary value of 100% of the work was how much? $8,000. You have completed 40% of the work. So 8,000 multiplied by 40%, 3,200. That's the monetary value of work that has been completed till now. So what will this tell you? Time, cost, or scope? On value. What shall I put in the bracket? What do you think? Scope. That's correct. So this is scope. The thing is, you can't compare time and cost. You can only compare scope with either cost or either time. So which one do you want to be higher, on a higher side? If to be in a better place in your project, do you want scope to be higher than cost or lower than cost? So that means in this case, scope is higher than cost, so your project is under budget. That's the reason your project is under budget. What about scope versus time? Which one you want to be higher? Scope versus time. For a project to be scope, you want to be higher because then only your project will be running early, right? If your time is higher than scope, that means you have spent more time than how much scope is completed. So this is, can we say this is the best case scenario? Scope is higher than both cost and time, right? This is the best case scenario. Worst case scenario will be scope is lower than the other two. So earned value is what you need to find out how your project is performing. So shall we add, we'll add earned value as well there. I'll add it there. But first of all, let me give you the formula for planned value. There's a formula as well for planned value. Planned value is percent work scheduled multiplied by BAC. Sometimes PMI can give you percent work schedule as well. What do you think? What's the percent work schedule after 2 days? Percent work scheduled. Total work schedule was 8 days. What's the percentage work scheduled in 2 days? How much percentage of work was scheduled in 2 days? 2 by 8 into 100, and that's how much? 25%. 25% multiplied by BAC. What is BAC? $8,000. Are we getting the same value that we found? Right, $2,000. Right, so sometimes PMI can give you this value as well, percentage work schedule. They might not give you this whole story. Can there be a formula for actual cost as well, or is it a raw cost? It cannot have a formula. Actual cost. Don't you think for actual cost you have to rely on your bank statements, receipts, bills, and all that? Would you agree? What do you think, all of you? Don't you think actual cost is not really, it cannot have a formula? It's totally based on receipts, bills, you can say account statements and all that. You have to look at your bank statements. There cannot be any formula. It's a raw cost. It's a raw data. Okay. So actual cost doesn't have any formula. Earned value. What's the formula for earned value? Percentage work completed, right? Completed multiplied by BAC. So that is 40% multiplied by $8,000. That's 32. Okay, let me put this on the graph. Earned value. So earned value per day. Percentage work completed. Let's say 40% by day 2. So 10% here, you know, by this 20%. This is what we know till now. By day 2, 20% of the work was completed. So can we get the earned value? EV. Let's say here EV would have been how much? What is BAC? BAC is first let's come multiply this by BAC. BAC is 8,000. I'll just put this BAC. All right, I'll take this. One sec. This is also BAC, right? Auto sum. Equal to percentage multiplied by this. No. Okay, I didn't take that as percent. 1 second. Just format cells. Where is percentage? Yeah. Okay. 100% it is showing 10. This same thing I want here. Just make it 20. And yeah, I don't want this. 1 second. I'll do this for this whole thing. Format cells, percentage. I don't want any decimal places. Okay. Yeah, that looks fine. I hope all of you are getting what I'm doing here. Right, so earned value equal to percentage multiplied by what? BAC, right? 800. I just pull this down. No, it's not 20%, right? It's 20% here. Here it's 40%. Right. 1 second. Okay, let's leave it. Let's keep it. Okay. Okay, that's 3,200. Shall I add this as well on the graph, right? So don't you think only planned value you would know for future? You would not know what's actual cost and earned value for future because things have not happened yet. All of you would agree with that? That just planned value you can see, you know, for future because that you have already planned. But actual cost and earned value, you don't know yet, right? Because you haven't really, you know, things haven't happened yet. So I'll click on add. I will add this. Second. This will be the data. Let me just do that. 1 second. Add. Series name is EV. Series value is, okay, that's done. All right. What do you think? Makes sense to you? Can you see how PV is running ahead? EV is running ahead of all the other values. Is that clear to everyone? How this is working? What do you think? Can you see the orange line? That's your EV. Yellow line actually, not orange. That's your own value. So you can see it's ahead of actual cost and planned value. Can we say? No, not, it's not your profit. It's your, it's your, it's your value, monetary value of work that has been performed, right? That has been completed. Monetary value of work that has been completed. Okay. So monetary value of the total work, how much is that? $8,000, right? That's your monetary value of all the work. How much work has been completed? 40%. So monetary value of the work that has been completed is 40% of 8,000. Okay. So that's what you see there. And actually, if you don't want to see this plan value cost, that's also fine. We can actually remove that. And we can start all these from 0. That could also work. Let me see that is possible. 0, 0, 0. Yeah, this looks not fine. We need day 0 as well. One second. Can we make it 0? How will it become 0 here? The starting point. It's not really starting from here. I want this to start from 0. I'm just checking whether it is possible or not. Because I want it to show from 0, but it's not really taking it. So I'm just checking if we can make some changes into the axis. Vertical is then no axis options, data axis, category number 0. I don't know whether that will work. No. Tick marks, interval between marks, 1 major type, minor type, labels, automatic, distance from axis, next to axis, numbers, general. Okay, no problem. Let's leave it. Yeah, not a big deal. I'll just keep it, starting from this. Yeah, this is fine. So this is how our earned value graph is looking like. But now we need to figure out few other things here. Okay. And let's see. It's not over yet, the earned value management. We got all these three values, that's fine. But sometimes what will happen is PMI will give you just these three values. Now you need to figure out whether your project is running under budget, over budget, late, or early. Right now you said that it's running under budget because earned value is more than actual cost, and it's running early because earned value is more than planned value. But there are certain variances that you can identify. So there is something called variance analysis that you can do. Variance analysis. I told you that we will discuss variance analysis. So here it is. So first let's talk about variances. There are two types of variances: cost variance and schedule variance. So what will be cost variance? Scope versus cost or scope versus time? Because we can't compare scope and time. So we have to compare scope with either cost or time. So cost variance will be scope versus cost or scope versus time. It says cost variance. So will it be scope versus cost or scope versus time? What do you think? Scope versus cost or scope versus scope versus, it would be scope versus time, you're saying? It says cost variance. When it says schedule variance, then it will be scope versus cost. Right. For cost variance, it should be scope versus cost, right? Because the next one is schedule variance, which will be scope versus time. So that's a different one, right? So it should be scope versus cost. You're comparing scope and cost because it says simply cost variance. So there can't be any other answer than cost, scope versus cost, right? So what does variance means? Let's say you have uh, you have $40. I have $30. What's the variance? What's the variance? $10. So you just subtracted, right, to find the variance. So cost variance means scope versus cost. So what are we going to subtract here? What does which value represents scope? Earned value. And which value represents cost? Actual cost. Right. So I hope the formula is clear. Very simple. Now schedule variance. What will be schedule variance? Scope versus cost or time? Scope versus time. So what will be the formula? Scope is earned value, time is planned value. That's how you should remember the form. Okay. So what's the cost variance? Find out. Cost variance is coming out to be 3,200 minus 2,400. That's $800. It's coming out to be positive. Is cost variance being positive a good thing or bad thing? Is it good or bad? Good, right? So good means under budget. Under budget. And vice versa. If it is negative, it would be over budget. Schedule variance, how much is it coming? 1,200. Schedule variance is greater than 0. So that is late or early? What do you think? Early. Early or ahead of schedule. And vice versa. Okay, so that's cost variance and schedule variance. Now, we have identified this. Now tell me, and what do you see through these variances, value of these variances? What are you able to see? Are we performing good in terms of time, or are we performing better in terms? If you compare your performance based on cost and time, in which department are you doing better than the other? In time or cost? What do you think? If you compare cost and time, which cost variance and schedule variance do you think, what do you think, in which department are you performing better, in cost department or in time? In the schedule department, right? Because that's where your schedule variance is higher, it's more positive, right? So you're performing better in terms of time here with respect to cost, right? That's how you can compare these two variances, but not a big deal. Now, let's say you have $40, I have $30. So one way to compare is find the variance. That means just subtract 40 minus 30, $10. That's the variance. What is the other way to compare these two numbers? You have $40, I have $30. One way to compare is variance, just subtract. What is the other way to compare? Apart from subtracting. What do you think? No, I mean, you have 40, I have 30. I can say that you have $10 more than me. That is one thing I can say. What is the other thing I can say? Can I say I have 25% less amount than you have? Or maybe I have, I have 3/4 the amount that you have. Is that another way, right? So can we say the other way to compare is ratios, division? Instead of subtracting, we can divide. So that is another thing that we can get. That's called indices, index. So there are two indices. One is cost performance index, which is called CPI, and another is schedule performance index, which is SPI. What is CPI? Scope versus cost or scope versus time? Cost performance, scope versus cost. So same formula we have to use, but instead of subtracting, what are we going to do? Division, because this is index, EV by AC. What about SPI? Can you tell me the formula of SPI now? EV by PV. That's it. So what is EV by AC will come out to be 32 by 24, 16 by 12, 8 by 6, 4 by 3. So that's 1.33. Yeah, 1.3333. What about this? Schedule performance index 32 by 20, 16 by 10, 1.6, right? 1.6 will be, yeah. So what shall I compare these with? Variances I compared with 0. This one, what shall I compare with to know whether it's good or bad? I mean, it's a ratio. So shall I, to know whether it's under budget or over budget, shall I compare with 0 or shall I compare with 1? With 1, right? It's a ratio. So greater than 1 is good or bad? CPI. CPI coming greater than 1, good or bad? Good. Yeah, under budget, right? If it's less than 1, that's bad. That's over budget. Because if it's less than 1, that means EV is less, AC is more. You are lagging, your scope is lagging behind cost, right? And vice versa. Okay. SPI is also coming greater than 1, which is good. Early, or you can say ahead of schedule, and vice versa. Okay, and we can actually put it here as well. Can have AC. Oh, sorry. First, let me remove this. Okay. This is, and you know, using Primavera P6, you can get all this very easily. So, in terms of software, but yeah, manually also you should know. cost variance and schedule variance. Cost variance will be earned value minus actual cost. So here schedule variance will be earned value minus plan value. We are just assuming that day one was linear with day two. That's why we are getting these linear values. CPI and SPI, same thing, equal to earned value divided by actual cost. So when you're doing it practically, do it using this Excel only. Okay, and that's why I'm showing you this for the practical purpose. For exam, you just need to know the formula, that's fine. And formula are very logical. If you try to memorize them, then you would not be able to understand. Now try to learn the concept, then only you'll be able to answer any question PMI puts in the exam. So I'll just yeah. So you know this schedule variance and all, you can actually show here as well. This difference between this yellow line and gray line, that's your what? Cost variance. And difference between yellow line and orange line, that's your schedule variance. So difference in this terms. So this is showing you the schedule variance. Now let's look into the last thing. So variance analysis is done. Remember, I told you that we'll also discuss trend analysis. So another 5 minutes. Although, yeah. So the last thing is estimate. What's your forecast for the cost? Can you tell me, just by looking at this whole story, at what cost are you going to end this project? How much money you're going to spend at the end of the project if everything goes like this? How much money would you end up spending if everything goes, if the performance goes like this? To complete 40% of the work, you have spent $2,400 actual cost. So to complete 100% of the work, how much money will you spend? Total money. 3,000, only 3,000? Uh, 40% you have to complete 40% work, how much money you have spent? This much, 2,400. So to complete the whole work, how much money would you spend total? 6,000. That's correct, because 40% 2,400, another 40% means 2,400 plus 2,400, 4,800, and 20% means 1,200. So 4,800 plus 1,200 is 6,000. That is one way. Another way is 40% of the work has been completed in 2 days. So in how many days 100% of the work will get completed? Just 2.5 or 3 days? Total 5 days. Yeah, another 3 days. That means total 5 days. 40% in 2 days. Another 40% work you will complete in another 2 days. And 20% means 1 day, because 40% is 2 days. So 40, 40, 20, 2, 2, 1. Total 5 days. Every day, how much are you spending? 1,200. 1,200 into 5, 6,000. So can we say the cost forecast is 6,000, right? And so logically also you can find this, but I'll give you a formula as well, because in exam PMI will not give you this whole story. They might just give you these 3 values and maybe budget at completion. Then how would you find out? So for that you need formula. Yeah, if they give you a story, you can find it very easily, logically. Estimate at completion. That's what we call it. One is budget at completion. That is something that you plan. Estimate is at completion is your forecast, EAC. So it is directly proportional to budget at completion and inversely proportional to CPI. Because if your CPI is higher, your forecast will be lower. Would you agree? CPI is higher, forecast will be lower. CPI is lower, forecast will be higher. How many of you agree with this? Would you agree that your cost forecast and your CPI is inversely proportional? That's why CPI is in the denominator. Agree or not? Don't you think CPI being higher means very much under budget? That means your forecast will go down, right? That's why these two are inversely proportional, right? So remember, CPI is always in the denominator. So what is BAC? 8,000 divided by CPI. Are you getting that value? Let me know. Let's do this calculation. EAC. I'll show you EAC here. Yeah, getting same. So 8,000 divided by CPI equals to 8,000 divided by CPI. 6,000. So on day one also, let's say if everything went well, focus was this. If anything changes here, then everything else will get affected. You know, if let's say just if just 30% of the work is completed. Then you can see forecast has again gone back to 8,000. Okay, since 40%. So this sheet will just change everything accordingly. Okay. This sheet we can use. Estimated completion is coming out to be, if you ignore the round off error, just take it as 4/3. You will not get round off error. So we are getting 6,000. So you can see it's actually under budget only. Forecast is coming out to be 6,000. What is estimate to complete? The last thing, estimate to complete. That means how much more money do you need to spend in order to complete the project if everything goes by the current performance. You have already spent $2,400. How much more money do you need to spend to complete the project as per your forecast, as per the current performance? What is estimate to complete? How much more money you need to spend to complete your project? You have already spent $2,400. Your forecast is $6,000. How much more money do you need? Yeah, that's correct. So how did you find it? EAC minus AC. AC, right? EAC minus AC. EAC is your forecast, which is $6,000, minus AC is 1,200. No, $2,400. What is that? That will give you $3,600. That's the end of earned value management. So it's a huge subject in itself, but for the exam, this much is fine. I mean, you now know considerably, what really this earned value management is. I'll just put here EAC minus AC. Where is AC? There it is. 4,800. Why this is lower? EAC minus AC. Yeah, 3,600, right? Can you see here ETC was 4,800? Now it has gone down to 3,600. It will go down as you move on. ETC, right? So that's your estimate at completion, and you can actually have that as well. Let me see if we can. I don't know what it is going to show, but I want a different. No, it's not what I want. Oh, for that reason, for this reason, I usually prefer manual graph for this one because it should show something like this. But it's fine. Yeah, this is enough. I mean, this is your earned value management. That's the end. So I hope this is clear to all of you. And this sheet you can actually use in your projects to do this whole calculation. And if anything I change here, let's say the painter was asking, let's say 1100, not 1200, everything will change, So for us, it's 1200. So I'll keep saying. You can see all these values. And these you can find using software as well, like Primavera P6. Even on Microsoft project, we have this. So if you remember this for this particular example, everything will be fine for you. There won't be any confusion. Okay. And if you look at the PowerPoint, they have shown this thing. Where is that? On value management. So look at this graph now. So PMI can just give you this graph and can ask you, where do you think the project is right now? So what do you think where the project is at this point? Let me ask you this point. On day 3, what's going on in the project? Is it under budget, over budget, late, early? What is going on? Under budget and early. Under budget because earned value is better than actual cost, so that's under budget. That's good. And it's lower than no, I think you're saying it's under budget and early. No, that's not correct. It's over budget and early. Let's see. So earned value is lower than actual cost, so that's why it's over budget, and it's higher than planned value. That's why it's early. Yeah, that is correct, right? So remember, all of you, earned value, if it is greater than your time parameter, then you're doing good with respect to time, because earned value is your scope. Yellow line is your scope. Scope is better than orange line, which is time. So scope is better than time. That means it's early. Scope is and the scope is not doing good with respect to cost. So that's over budget. So it's over budget and early. This at this point. I hope this is clear. Anyone has confusion on this? All fine. You can just check again those things that we did. See, those who are having confusion, this is your actual cost. This is your earned value. This is your planned value. So what do you think is happening? Earned value is greater than planned value at this point on day 3. What does that mean? Early. You're doing good with respect to time. Earned value is less than actual cost. What does that mean? Over budget. You're doing bad with respect to cost. Let me ask you one more time. Tell me this day. What's happening? Here. On day 5. Right. So what is that? That's over budget, right? And what about the time? It's over budget, it's true. What about time? Yeah, is it on time? Can we say it's on time? Right? Because earned value and planned value both are matching, both are at the same point. Right, that's correct. So it's over budget and on time. What about this on day 8? Over budget and late. Can we say this is the worst case scenario, right? Because your scope is not only lower than cost, it's lower than time as well. So that's the worst case scenario. So these kinds of questions can be asked in the exam very easily by PMI. What do you think? Just give me a confirmation if this earned value management is clear to all of you. Same, whatever we have discussed, you will see here. You can see schedule variance, SPI, cost variance, CPI, EAC, etc. So I've also shown you how you can get these formulas. I would suggest you to try these few examples that they have mentioned in the activity. Okay, so I'll just stop the recording here.